Hello friends. So today the time is 11:18 and 13th of April 2026. So I'm going to start study here at my lab. So starting the timer of 50 minutes. Okay, I started. So let's start the remaining lecture of Unity. My pathway was game development as I showed you in earlier lecture, and I will also make the playlist for this lecture, all these lectures. So let's start by creating a basic 3D game. Okay, so first some things I want to say, that what I will learn, what you will learn in this pathway. You can choose between 3D game or 2D game, whatever you want, or maybe both, but this unit specifically focuses on 3D track. So if you are not interested for 3D, you can skip this. Okay, so whatever I build first a role a ball game. Okay, starting point for a personalized video. Okay, and second I will also learn C# programming, gameplay mechanics, AI navigation, and basic game design. Okay, and total the XP will be 120 20 total 120 XP I will earn this. Okay, now going to start it. So it's just opening. Now introduction to unit 2. This is the unit 2. Okay, the summary is that I already told you. Now the overview is that in this unit what I will create a roll a ball game. Okay, now I will show the game. See this ball is rolling, and every that points are just what's it disappearing when it touching that, and when it is cross the all the coins, then it will say you win, otherwise you lost. So in this game you use arrow keys to roll a ball around the play area while trying to collect pickups, all the pickups you have seen already in this video. I will play it again for you. See these are the pickups, these yellow color pickups, you have to collect it. And if you get caught by enemy, you lose. You have to be careful from enemy, otherwise you will lose all the points. Okay, in this tutorial you will get an introduction to. Okay, I'm going to start it. Okay, so one second, what is opening? I have to log in. I think it's log out. Now it's login. Okay, I have completed it. Okay, mark is complete. Now what you will learn, what will you learn, or what will I learn? Okay, as we will create this project, we will learn some fundamental Unity skills. What the fundamental skills that we will learn? We will use the Unity editor. I already saw that Unity editor in the previous lecture, you can see that. Okay, and its built-in capabilities to set up simple game environment, and how to write your own custom scripts, C# scripts. Mainly we in Unity we use the C# programming to create this game functionality, and how to create basic UI, user interface, to improve the game experience. Okay, how to build your game so that other people can play it, enjoy it, have fun. Okay, so how to, there's a video for this. Okay, let's start the video.
Welcome to the Rollerball project. In this beginner project, you're going to make a very simple but playable game using many fundamental game development concepts. In your rollerball game, the player will control a ball rolling around the game board using the power of physics. Your game will use player input from the keyboard to apply forces to the ball and move it around the game environment. It will also detect contact between the ball and other objects in the game so they can be collected. When the player has collected all the objects, the player wins. In this learning project, you'll use the Unity editor and its built-in capabilities to set up a simple game environment. Write your own custom scripts to create the game functionality. Create a basic user interface to make the game feel more engaging. Build your game so other people can play it. You won't need to import any assets for this project. You'll just need to use Unity version 2019.3 or higher. That's it. You'll create everything else you need in the Unity editor. If you don't already have Unity downloaded, go to the Unity Hub to get ready. First, you'll complete the Setting Up the Game project. Let's get started.
Okay, let's get started. Thank you so much for watching this. And now I can mark as complete. Okay, mark this step as complete. Now, a note about learning C# script. If this is our first time learning to program in any scripting language, it's confusing, so that's okay. If it's confusing, if it's overwhelming, it's okay, it's normal. It takes a long time to get comfortable with programming, but with enough repetition, enough practice, you will manage everything. Okay, if things seem confusing, this is completely normal. Just keep going with it. The concept will slowly becomes clear over time. Okay, I can complete this. Okay, how can you use this game for your personal project? You can use in many scenarios. Okay, so these tutorials have step-by-step instruction on how to make this very specific, very simple role a ball game. However, later on you will be asked, I will be asked to fill out game design document, GDD, game design document. Okay, that will outline how your own game will have a distinct theme, style, and set of gameplay mechanics. Throughout the course, we will use the example below, where a crab is trying to chase and pinch a beach ball, which also started with a simple roller game. Okay, rollerball game. Okay. So you can see this here. Okay. You can see ball is rolling and sound is that's thing you can do. But think about it this way: simple game should be the foundation for infinite game being possibility. This is a player trying to collect things and avoid an enemy. How many completely different games are there that share the same conceptual starting point? You will be able to take this core mechanic and expand it into something completely unique, different. Check out three example below like this. You can check out rollerball. I have to step it. This thing. This is another one, and I will slide it. This is the ball going in a what's it slides. Okay, and this is a jigsaw. Jigsaw, that maze type. Check out the three examples. Okay. Now is complete. Okay. Now next steps. Now you know what to expect from this unit. This unit number 2 of our game development pathway at Learning Unity website. You can see the website learn.unity.com, and you can join this pathway with me. Okay, together we can learn and grow as a game developer. Okay. Now you can know. Now you know what to expect from this unit. Creating a basic game. You can read this. Complete this tutorial. Okay, it's completed now. I earned 10 XP. It's really great. 10 XP I earned. So I rating this. Clear instructions are there. And I provided inspiring and project success. I think this one. Okay, continue to next. Okay, now setting up the game. How to set up the game? 20 minutes. Okay, let's start the. So in the summary of this, that we will use Unity editor, write our own custom scripts or user interface. We will improve the game experience and build our game to other people can play it. Okay, let's start. In this first roll a ball tutorial, what you will do, you will create a new Unity project, set up workspace, create a position, some basic objects for your game, and configure the lightning and game background. By the end of this tutorial, your game will look something like this. You can see this. In this way, your game will look. Okay, you can mark as complete. Before you get started, you do need to install the latest version of Unity. I already have. If you're not, you can click this link and go to the and you can set up your project. Okay. Now new to this Unity, okay, and I can mark this complete because I already have the Unity 6 version and I have already set up that. Okay, create an Unity project. Follow the video or text instruction below to select a project template and create a new project. Okay, select a project template. Open the Unity Hub. I already opened. Okay, I should what should I do? I side by side open it. Okay, so it will be easier to for me to uh, have the tutorial better. Okay, not this one. Okay, not this one. So what I do? Open the Unity Hub. I already opened. Login. I have selected new project. I selected the new project. Okay, whatever is given, I'm just doing. Universal 3D template I selected. Okay, and then select download template. I already download. I already have it. Okay, and now next thing is that create the new project. In the project setting, enter the role ball in the project name. What I name this project is that roll a ball. Okay, in the project name box. And now what I will do next, I will create the project. Roll a ball, I given the name, and now I will create the project. Okay, it's creating, as you can see. Meanwhile it's creating, I will do something else. I will do data science course. Okay, I'm starting this course. Side by side I seeing what the progress. Okay, I have to log in again. Let's log out. I will log in through GitHub. Okay, I already have completed some lectures before, as you seen before. So first I will see the progress, where the progress is. Okay, here the progress. So I completed till this Jupyter Lab and Jupyter Notebook tutorial. Okay, I'm starting from here. How to establish this Jupyter Lab and Jupyter Notebook. Okay.
Alright guys, अब हम interesting topic
This is a paid course, so the screen will be black. You have to purchase this course for. Okay, this is different from Unity. I'm just doing for without wasting time. Okay. I'm doing this course parallel.
तरफ आगे बढ़ रहे हैं जो कि है जुपिटर नोटबुक एंड जुपिटर लैब। क्या है जुपिटर नोटबुक, क्यों यूज करूं जुपिटर नोटबुक, क्यों यूज करूं जुपिटर लैब? सबसे पहले मैं आपको बताना चाहता हूं कि जब भी हम डेटा साइंस के प्रोग्राम्स लिखते हैं तो इट्स ऑलवेज बेटर टू एग्जीक्यूट कोड इन डिफरेंट चंक्स। उसका रीजन ये होता है कि जब हम डेटा लोड करते हैं तो हम कभी डेटा पर एक ऐसा फंक्शन लगाना चाहते हैं जो कि हमें मान लो शुरू के 5 रोज दे दे, कभी कभी हम चाहते हैं कि हमें लास्ट के 4 रोज दिख जाए, कभी हम चाहते हैं कि जो हमने लास्ट टाइम एग्जीक्यूट किया था उस कोड को हम डिलीट कर दें। ये सारी चीजें जुपिटर नोटबुक हमारे लिए बहुत आसान बनाती है और इसलिए ये चॉइस है डेटा साइंटिस्ट की जब भी पाइथन प्रोग्राम रन करना होता है। अगर आपको ये चीज बिल्कुल समझ में नहीं आई तो मैं आप लोगों को जुपिटर नोटबुक इन एक्शन दिखाऊंगा, उसके बाद तो ये सब चीजें क्लियर हो जाएंगी। तो आ जाओ कंप्यूटर स्क्रीन में और यहाँ पर देखो कि क्या होता है जुपिटर नोटबुक। तो मैं जल्दी से एनाकोंडा प्रॉम्प्ट में जाऊंगा, लिखूंगा एनाकोंडा प्रॉम्प्ट और एनाकोंडा प्रॉम्प्ट खुल जाएगा। अब यहाँ पर एक बेस एनवायरनमेंट वेरिएबल बना हुआ है। अब मैं यहाँ पर लिखूंगा
I will do the same instruction. I follow the same instruction. Okay, I will first open anaconda prompt. Okay, anaconda prompt I open. Okay, the best instruction he has given that COND. Okay,
conda
conda env. Once again I see
env list और यहाँ पर जो भी
okay, I will also do this conda env list. And now when I press it, it's taking time because many things are going on, but I have to wait. Okay,
वर्चुअल एनवायरनमेंट से मुझे देखने को मिल जाएंगे। जैसे कि आप देख सकते हो यहाँ पर एक तो बेस एनवायरनमेंट है, एक बुक CNV है, एक हैरी एनवी है। मान लो मैं स्विच करना चाहता हूँ बुक CNV।
now it's open. So when I enter this command conda env list, then all the environments that I have already created, one is already that is open is base, and that already that I created in previous lecture. As you can see, books env and mypal env is the new one that I created by myself. And how I created, you can see the previous video, or you can follow the handbook by purchasing this course. Okay.
तो मैं लिखूंगा conda activate books।
Now it's a good course. You can do this whatever he's telling. Conda activate books env. Okay.
env एंटर मारूंगा और आप देखो बुक्स env एक्टिवेट हो चुका है। अब मान लो मैं एक फोल्डर बनाना चाहता हूँ और मैं यहाँ पर लिखूंगा mkdir और मैं फोल्डर बनाऊंगा बुक्स डैश प्रोजेक्ट्स। ठीक है, प्रोजेक्ट बुक्स पर।
Okay, let it be activate very soon. Soon it will be activated, and soon this Unity will be done. Let's wait. Whichever will come fast, and I will do that. Okay, it's activated now. So I will make directory of books project. Now I made the directory of,
प्रोजेक्ट मैं सीडी करूंगा इस प्रोजेक्ट में और मैं इसलिए
and I will change the directory to, it's currently it's a users directory. I will change, no, mpsync directory. I will change the directory to books projects, and now I am different directory, books project directory. Okay.
फोल्डर बना रहा हूँ क्योंकि मैं चाहता हूँ कि मेरा जो भी काम हो इस बुक्स डैश प्रोजेक्ट नाम के फोल्डर में हो। तो मैंने अपने यूजर फोल्डर में एक फोल्डर बनाया बुक्स प्रोजेक्ट और उसमें सीडी कर लिया, यानी कि मैंने डायरेक्टरी चेंज कर ली और मैं अंदर आ गया इस बुक्स प्रोजेक्ट नाम की डायरेक्टरी में। अगर आप लोगों को नहीं पता है क्या है तो मैं थोड़ा सा एक्सप्लेन करता हूँ। तो यहाँ पर जैसे कि आप देख सकते हो कि मेरे यूजर वाले फोल्डर के अंदर एक बुक्स प्रोजेक्ट नाम का एक फोल्डर है जो कि खाली है, जो कि मैंने बनाया है और मैं चाहता हूँ कि जो भी काम मैं करूँ इस फोल्डर के अंदर करूँ। और किस एनवायरमेंट का यूज करके करूँ? इस बुक्स एनवी नाम के एनवायरमेंट का यूज करके करूँ। तो मैं इस बुक्स एनवी नाम के एनवायरमेंट का यूज करके इस फोल्डर में प्रोजेक्ट बनाना चाहता हूँ। तो मैं ऐसा कर सकता हूँ, मैं क्या करूँगा, यहाँ पर लिखूंगा conda CONDA इंस्टॉल और मैं लिखूंगा जुपिटर JU।
Okay, I will install Jupyter here in this directory, books project. Okay, conda install Jupyter. Okay, I press the enter button. Okay, now it's processing is going on. I think it's not. Okay, this platform is Windows 64, and I want to proceed. Yes, I want to proceed, and it's installing all that modules that it contains. You can see.
PYTER और ये क्या करेगा, मेरे लिए जुपिटर इंस्टॉल कर देगा। मैं वाई एंटर करूंगा और ये सब इंस्टॉल हो जाएंगे इस पर्टिकुलर एनवायरमेंट वेरिएबल में। जो जो चीज़ें चाहिए मुझे वो सब इंस्टॉल हो जाएंगी। आप देखो ये तमाम पैकेजेस मेरे लिए इंस्टॉल कर रहा है। नोटबुक नाम का एक पैकेज है, पैनडॉक नाम का एक पैकेज है, ये सब इंस्टॉल कर देगा ये इन अ मैटर ऑफ सेकंड्स। और जैसे ये इंस्टॉल हो जाएंगे सारे पैकेजेस, उसके बाद ये ट्रांजैक्शन वेरीफाई करता है, जो भी कर रहा है ये सब चीज़ें करने के बाद आपको फाइनली आपके एनवायरमेंट में पैकेजेस इंस्टॉल होकर मिल जाएंगे। और उसके बाद आप क्या करोगे, सिंपली जुपिटर नोटबुक नाम का एक कमांड है वो आप रन करोगे और आपकी एक इंटरैक्टिव नोटबुक खुल जाएगी, जो कि मैं आपको दिखाऊंगा। उसका हम एक डिटेल टूर भी लेंगे। तो जैसे कि आप देख सकते हो कि यहाँ पर मैं जुपिटर नोटबुक स्पेस देकर लिखूंगा, मैंने लिखा जुपिटर स्पेस नोटबुक और एंटर। और जैसे मैं एंटर मारूंगा आप देखो यहाँ पर कि ये गूगल क्रोम में मुझे खोलने को बोल रहा है। तो मैं क्या करूंगा, मैं इसको बोलूंगा ऑलवेज ओपन इन गूगल क्रोम और यहाँ पर ये देखो मेरी जुपिटर नोटबुक खुल चुकी है। तो ये पेज आपको देखने को मिलता है। यहाँ पर मैं एक नई नोटबुक बना सकता हूँ। तो मैं न्यू पे क्लिक करूंगा, पाइथन 3 पर क्लिक करूंगा और मेरे लिए एक नई नोटबुक बन गई है। इस नोटबुक को रीनेम करने के लिए मैं यहाँ पर डबल क्लिक करूंगा और इसका नाम रखूंगा फर्स्ट नोटबुक, कुछ इस तरह से। नोटबुक क्या होता है जुपिटर में, नोटबुक क्या होता है, नोटबुक के अंदर कोड होता है, इन्फॉर्मेशन होती है। किस तरह का कोड और इन्फॉर्मेशन हम लोग डाल सकते हैं ये मैं आप लोगों को बताता हूँ। लेकिन उससे पहले मैं आप लोगों को दिखाना चाहूंगा कि जिस फोल्डर में हम लोग काम कर रहे हैं ना उसमें हमने एक
I have stopped it because it's already Unity is already open, and all that procedure of Jupyter notebook and doing other work I will do whenever I get stuck. Okay. Now, I am this. Next thing I have to do is that okay, I just yes. Done. Okay, it's already done. So now I'm again in the same Unity project because it was opening, so I was not wasting time. So I was doing parallelly another course, data science course, but now it's open. So let's start our game development course again. Unity projects already I have open. Now next step is that in the project setting we have to go in the project setting, where the project setting here file, and you can see here build profile. There is a play setting. Okay. The project setting, enter role bar in the project name box. Select the location box. If not, start. Okay, I done already this. I have done already this. Okay. I can mark this complete. Okay. Location box. Okay, I have done this. Create a new scene. Okay. Now to scene, create a new scene. Follow this video text instruction below to set up your workspace. Create a new scene from that template and save your scene. Okay. Set up your workspace. Make sure the default layout is selected from the layout. Okay. The default layout is selected. This layout is default. Okay. let's create a new scene from a template. Go to scenes and now creating a new scene. File, new scene. Okay, select basic URP. Basic URP is this one. I will select it and press the create. Select the create and save the scene. File, save as. File, save as. And what I will name it? I will name it mini game. Okay, and save the same scene in the folder name scenes. Okay, I have to save the scene in the scene name mini game in the scenes folder. This is saving. Now I have done this. Now I will open this mini game. Okay, some call is there, so I have to stop it. I will continue after attending the call. Okay, I'm stopping this as well. Okay, I'm going to continue the lecture. Some important call was there, so I was attending here. So okay, let's start the lecture. Okay, this is already I have done. This is already I have done. I'm closing it. Now this is the new project. This is the mini game that I already opened. Now create a primitive plan. Game 3D project. Now plan. Okay, it's plan. Alternative and hierarchy windows. Select the add menu, 3D project and now plan. Okay, you can do the both. So both alternative you can choose one select. Now at the top of the inspector window you can see this is the plan is there. Now with the ground game object select it in the upper right corner of the transform component. Select the vertical menu. I have to name it or what I have to do? Reset the position of the plane. Okay, I have to rename it. I rename it ground. And in the upper right corner of the transform, this is the upper right corner. Select the menu. So the vertical menu. Okay, I have to reset. Okay. What is that? I have to see the video. I think it's very difficult to identify where is the menu. I think this is the older version that they are talking about. It's totally different.
Now, let's get started and create a game board or playfield. You're going to do this by using a primitive plane. Primitives are simple pieces of geometry which come bundled with the Unity editor. They can be useful for creating simple prototypes without the need of an artist. Planes are two-dimensional surfaces. In this case, you'll be using a plane as the ground for your game. all objects in your scene are game objects, including the plane. To create a plane game object, either go to the menu and select Game Object, 3D Object, Plane, or you can go to the hierarchy and use the Create menu. Next, rename your plane game object Ground. You can do this by either selecting the game object and using the Enter key to allow editing, or by the title box in the inspector. Type in the new name and press Enter or Return to confirm this change. Then, select the vertical ellipsis menu in the upper right and reset the transform component. This will place the game object at the location of 0, 0, 0 in your scene. This is known as the origin point of the world, and this is where all of the coordinates in the scene are calculated from. Cool, right? Make sure the ground game object is selected and the cursor is over your scene view. Then press F to see the entire game object in the scene view. You can also select Frame Selected in the Edit menu. In the scene, you can now see grid lines indicating a plane on the y-axis.
As you can see.
You can use the Grid Settings menu at the top of the scene view to change the axis and opacity. Next, you'll configure the plane for your game.
That's good. Okay, this is how I completed. Marcus complete. Scale to the ground. Scale the ground. Follow the video. Okay, whatever I do, I will follow just the video. Instructions are really very confusing for me. Okay.
Now you need to change the scale of the ground plane. You can do this in 3 different ways. You can select the Scale tool using the hotkey R and simply grab the axis handle you want to change and drag the handle to rescale the plane. You can also click and drag on the title of the fields you want to change in the transform component found in the inspector.
You can.
Alternatively, you can type a value directly into the fields in the inspector. You can tab between fields and hit Enter to confirm your choice. Whichever approach you take, set your X and your Z scale values to 2.
You can do here.
Now remember, a plane has no volume, so scaling the y-axis will have no visual changes unless you go into negative numbers. In this case, the plane, which is a single-sided object, will simply face the other direction. If you place your plane in the scene and you can't see it, check your orientation between the plane and the camera to make sure that you have the correct value of 1 in the y-axis of scale. This plane is looking good. Now it needs something to roll on it.
Okay, thank you. Increase the scale of the plane at the ground. Activate the scale by pressing the R hotkey. You can press R or you can to activate it, and for F for framing it. Drag X and Z handles to increase the size of the plane. You can do this thing also. Okay, fine. X and you can drag X and Z. Set the precise scale in a transform component. Set X and Z scale to 2.0. Okay, and do this. Okay, I mark this step is complete. That's okay. Create a player game object. Now follow the video text instruction below to create a square for the player and then position it in, at the center of the ground. Okay.
Now that you've created a playing field for your game, you're ready to create a player game object. For this game, That will be a Unity sphere primitive. To create the sphere, in the hierarchy, select the Create menu, and then select Sphere. Rename the sphere Player. Reset the transform to make sure it's at the origin point of the scene, 0, 0, 0. Either select Edit.
One second.
Either select Edit.
Okay, you can also do this by one step, just pressing the reset button. Now you can see the ball is here, sphere is there.
Frame selected in the top menu. Or, while the cursor is over the scene view, press the F key on your keyboard. This will focus the scene view camera on your new sphere game object.
Okay.
Do you see how the sphere is buried in the plane?
Yes.
This is because both game objects are in the exact same location in the scene, the origin point, or 0, 0, 0 on the X, Y and Z axis.
0, 0, 0.
Now you need to move the sphere up until it rests on the plane, so the player can use it as a playing field.
Okay.
All Unity primitive objects, cubes, spheres, capsules, have a standard size.
Okay.
They are either 1 by 1 by 1 or 1 by 2 by 1 Unity units of measurement. Unity units can be anything you want for your game, centimetres, inches, etc. But default convention used by most people and by the Unity lighting and physics systems is 1 unit is equal to 1 metre.
1 unit is
If you raise the player object up by half a unit along the y-axis, it will be perfectly on top of the plane.
okay.
To do this, in the inspector, find the transform component.
As I'm doing.
Set the position y value to 0.5. Great! Now that you've set this up, in the next video, you'll think about the lighting in the scene of your game.
That thing you have to do for the instruction, and you have to do it by yourself. Okay. It's better to watch video instead of reading the instruction because it's very engaging. Adjust the default lighting. Okay.
You've created the basic elements to start working on your game, but what about the lighting and visuals? If you switch from the scene view to the game view, you'll see that the player game object is lit and it casts a shadow on the plane. This is because all new Unity scenes come with the default skybox and a directional light to represent the sun.
Yeah.
Let's tweak this value to adjust the scene a little. In the hierarchy, select the directional light and then review it in the inspector.
Yeah, I selected.
Change the tint of the light from a yellow to a pure white. Do this by selecting the coloured selections.
1 second. I have to select this direction light. I have selected already. Now I go to this here and change the color. Okay, change the color of it. Okay, and go here. Not now. Change the color. What color C choose? I just
Square
select the
to bring up the colour wheel.
color blue. C is going to change it to blue. Okay, let's see.
You can use the colour picker to choose a colour. To get specific results, it's best to select the exact values. For solid white, set the RGB values to 255, 255,
Okay. Okay, C is selecting 255, 2 white light, 255, 255, 255. Okay, this is the code language you can use. This is RGB 255. You can select this, and 255 again select this, 255 again select this. This is perfectly white directional light. Okay, you can select this. You can see now it's totally white, totally white.
and 255. This is looking much better.
Yeah.
However, the grey player sphere is difficult to see on the grey background. In the next video, you'll add some colour to the game.
Okay, it's really looking very cool. And you can change the RGB from 0 to 255. Because I want the white color, I take all the RGB into 255 ratio, so I get the white color. But for changing different color, you can change the ratio according to it. You can select, you can see here, here you can change the ratio of different RGB. Okay, and now I'm going to mark as this step as complete. Once again, what is going on? Mark this step as complete. Now add colors with materials. Okay, now I'm going to add colors with the materials. Okay.
Okay, let's add some more contrast between the player object and the floor plane. To add colour or a texture to a model, you need to use a material. This project doesn't use any textures, but we will quickly review what's included in the URP lit material. First, let's create a new folder in our project to hold the materials. In the project window, select the Create menu and then Folder. Rename this new folder Materials.
Okay, we're going to assets. Then I'm going to select materials. Okay. Okay.
With the Materials folder selected, use the Create menu again and this time select Material. See how the material was created in the Materials folder? This is because you had the folder selected when you created the material.
I create a new material here. I created
Rename this material Background.
background. Okay, I can rename
Next, let's change the colour of this background material.
background.
In the project window, select the background material and review the inspector. In the Surface Inputs section, the first property is Base Map.
Okay, best.
Select the Base Map's colour field to open a colour picker. Change the colour to a pale grey.
Validate.
You can set the RGB values of 130, 130 and 130 to get the exact shade that the example game uses.
130.
The next map represents both metallic and smoothness. As this Unity project does not use textures, you can adjust these independently. First, set the metallic to 0. Then change the smoothness to 0.25 to create a matte material. To apply the material to the plane, select the material in the project window, then drag it onto the plane in the scene view. If you drag it over the player sphere, it may try to assign itself there.
Assign.
If it does this, don't worry, use Ctrl or Command Z to undo, and then assign it to the plane. Now the background is ready, let's create another material for the player. In the project window, select Create, Material. Name this new material Player. In the inspector, select the Base Map's colour field to open a
1 minute. Let me do the step-by-step things. Okay, I'm creating the player of that object. Where is this material? Okay, and renaming it that player for giving it to player. Okay, you can see here the background material is assigned to this ground plane, and there is no material assigned to player, so we are making the player material for assigning it to player game object. Okay, so we are assigning the
colour picker. Set the RGB values to 0, 220 and 255, which is a nice light blue.
once again 200, what the values? 0 to 20 to 55 for light blue. Okay, you can select this color. Where is that color? 0 to 50. or 255. This color you can select.
220 and 255, which is a nice light blue. Next, set the metallic to 0 and change the smoothness to 0.75 for a shiny finish. Then, as you did before, drag the material from the project window onto the player sphere in the scene view. Great!
Now it's great.
You've almost finished setting up for the game.
To play
But let's make one additional change and rotate the main directional light so that there is better lighting on the player. In the hierarchy, select the directional light and identify its transform component in the inspector. Change its rotation to 50, 50,
50
and 0. This will give it a better silhouette.
better light.
Now you've created a player game object and a background playfield. Awesome! In the next section of this project, you'll get started with the game functionality and write a custom script to get the sphere moving around the playfield.
From every side you can see it's looking very great. Okay. Dramatics. Right, I can do this. 50, 50, 0. This is good. And these materials I have already done. I have already made. You can see here. What can I do? I can change that. Now you see background and plan both together. Okay, finally. Okay, next step is I have to save this Ctrl S. Now I have to rate it. Really very engaging instructions are given by the engaging instructor. Next. Okay, next is that we are going to move the player. We are moving the player. In the second role all tutorial, you will add a rigid body to the player sphere, so you can use the Unity physics engine. Write your own player control script in C# to make the spheres respond to player input, and test your script, fix error that types. These are the scripts. These are the resources of the scripts that we will use. I can open these in new tabs for accessing them. Okay. But we will write from ourselves. We will not just copy and paste. We will understand and write by ourselves again. Okay. These are the scripts. Okay, these are not scripts. These are, I think, transcripts of everything. Okay. Okay, we are starting from this. In this tutorial, we will add a rigid body to the player sphere, so we can use the Unity physics engine. Write our own player control C# script to make sphere respond to the player input, and test the script and fix error. Okay. By the end of the tutorial, we will look something like this. We have this game like this. Okay, just completing it. Add a rigid body to the player. Okay. Component to the. Okay, we are going to start with. Okay, side by side, I am doing this with me.
Now that you've created a player object and a game environment, it's time to think about how the player game object should move and behave.
Okay, I'm doing this.
It needs to be able to roll around on the game area, bump into walls but stay on the ground and not fly off into space, and collide with collectible game objects to pick them up. These things require physics. To use physics, the game object needs a rigid body component. To attach this, you need to, in the hierarchy, select the player game object. Next, in the inspector, select Add Component, then search for Rigid Body and add it to the sphere.
I added it.
You can collapse or expand the component view by clicking on the component's title bar.
and expanding and collapsing.
Whenever you expand a component like this, it will also toggle the relevant gizmos for that component in the scene view.
See this? It's giving.
Okay, now that the player game object can interact with the physics system, it's time to apply some forces to it. In the next video, you'll install the input system package so you can do just that.
Okay, thank you so much for watching. Now I have to turn it off. Yeah, we have given the reset body to our player game object. Now next step is that we will add player input component. Okay, so we are going to start the video. I'm going to start the video.
Let's add the player input to the sphere. First, in the hierarchy, select the player game object.
The way I selected.
In the inspector, select Add Component. Then, search for and add player input.
Player input, okay, and enter it.
This will help you get the player movement for your game set up quickly. The player sphere still won't move just yet,
Yeah.
but you will be able to access the information this component provides about control devices,
Okay.
such as the player's keyboard, using a script to control the player object's movement.
Yeah.
In the next video, you'll get started with that script.
Okay. Let's start it. So now we are creating our script, C# script for player control to control that player. Okay. Save it.
Before you create the script to control the player object's movement, let's make a folder to organize script assets. In the project window, click on the Create menu and choose Create Folder. Rename this folder Scripts.
Scripts, okay.
Now you're ready to create a new C# script.
Okay. Now
You'll be using C# as the programming language, as this is what Unity supports. To create a new script, you have some choices. You can go to the top menu and select Assets, Create, to create a new C# script. You can also use the Create menu in the project window. But what might be most efficient in this
Yeah,
case
and then
is to
this off.
select the player game object in the hierarchy
You can use
and then use the Add Component button in the inspector. The Add Component menu contains the option New Script.
okay. You can just this.
You can select this to create and attach a new script in one step.
Yeah, this is very cool.
Name the new script Player Controller. Select Create and Add, or press the Enter key to confirm your selection. Unity will create, compile, and attach the script to the selected game object, in this case, the sphere called Player. Creating a script directly on a game object creates that script asset on the root.
1 second. I am not able to create what happened. I have to see. There script is you have to create. What is the script? 1 second. I have to edit again. I think something is going. Okay. Now I have to name it player input. The name of the script is player input. Okay. I'll name it. Something is going on. One second. I
Or top level game object key to confirm your selection. Unity will create,
player input, player control script.
add, Player Controller. Select Create and Add, or press the Enter key to confirm your selection. Unity will create, compile, and attach the script to the selected game object, in this case, the sphere called Player. Creating a script directly on a game object creates that script asset on the root or top level of our project files.
Now it's created.
shown in the project window. To keep things organised, move the player controller asset into the scripts directory you created. Next, select the script in the project window. You'll be able to see a preview of the script asset in the inspector, but you can't edit this text. Let's open the script fully. There are two main ways to do this. You can double-click on the script asset in the project window, or you can use the Open button in the inspector when the script is selected in the project window. Each of these options will open the script in your preferred script editor. This is Visual Studio.
One second. Something is going very difficult. Of these types. Okay, I open this script. Now what I have to do next? One second.
In the inspector when the script is selected in the project window. Each of these options will open the script in your preferred script editor.
I have to open that script. Where is the script?
This is Visual Studio by default
I'm not able to see the
on the script asset in the project window, or you can use the Open button in the inspector when the script is selected in the project window. Each of these options will open the script in your preferred script editor. This is Visual Studio by default. Don't worry if this takes a little bit of time to load.
One second. Where is that script? It didn't open here. Assembly. Something is different open, you know. Ball. Go to scripts. Where are the scripts? Here are the scripts. This is the play control. This is the script that we have found. This is the script. Now I am able to see it. Something issue is there. Update. I am doing the update with this. Okay.
Load, especially if this is the first time you've opened your script editor.
Okay.
In the next video, you'll begin to write your first custom script to get the player sphere moving.
Okay. Write the onMove function declare. Okay. For the video or text. Okay, we have to declare here onMove function.
Okay, let's get started with your first script. You'll see that there is some code already there. This is a template to make it easier to get started writing Unity scripts. A function is a way to group code under one name. There are two functions included in the script template, start and update. You can use the function name as a shorthand or call the function instead of writing the same code every time. The code in start is called when your game starts, and the code in update is called once per frame of your game. You won't actually need the update function in this script, so remove that code for now. Before you begin writing code, let's think for a moment. What do you need to do with this script? The script needs to check every frame for player input and then apply that to the player game object every frame as movement. Where will it check for the movement? The input system has a method you can use to get the data from this input. Where will it apply the movement? There are two things you can use to apply this: update and fixed update. Update is called before rendering a frame, and this is where most of your code will go. Fixed update, on the other hand, is called just before performing any physics calculations, and this is where your physics code will go. You will be moving the ball by applying forces to its rigid body. This is physics. So you will put this part of the code in fixed update. Okay, let's get started. Because you are using the input system, you need to add its namespace to the script. Namespaces are a collection of classes and other data types which can be imported at the start of your scripts. There are already namespaces used in the template. There are lots of different namespaces. The additional one you need for this script is the input system namespace. Add a new line below the first namespace. Write using Unity Engine .input system semicolon.
1 second. I will complete the script after some break. I already very thirsty and I want to go to biobag also. So I'm going to pause it off. Okay, going to pause. Hello friends. So yeah, I am going to continue that lessons that I was already studying. Okay, this lectures where you see I was writing the script. So let's write the script. I already opened that script here. Yeah, here. Yes, install the update 8.7 for downstairs. It's better to run all game development. Yeah, this is good. I don't know. Fine. Let it download. Okay. So I was saying that I'm going to continue this lecture, and that was remaining. It's updating, so I have to wait for a while. Okay, what I can do now, I can continue that. 1 second, I will try again. If it open, it's open. I think it will not open. Setup is there, no? Okay, let it be installed. So let's start the Jupyter Notebook. Refresh it. Open the terminal. Okay. Okay. I will minimize it, otherwise very difficult to understand what I am doing.
उसका हम एक डिटेल टूर भी लेंगे। तो जैसे कि आप देख सकते हो कि यहाँ पर
1 second, I is already done. I have to start the time here. Sorry. Fine. Sorry, done. And let's start.
ट्रांजैक्शन वेरीफाई करता है, जो भी कर रहा है, ये सब चीज़ें करने के बाद आपको फाइनली आपके एनवायरनमेंट में पैकेजेस इंस्टॉल होकर मिल जाएंगे। और उसके बाद आप क्या करोगे, सिंपली जुपिटर नोटबुक नाम का एक कमांड है, वो आप रन करोगे और आपकी एक इंटरैक्टिव नोटबुक खुल जाएगी, जो कि मैं आपको दिखाऊंगा। उसका हम एक डिटेल टूर भी लेंगे। तो जैसे कि आप देख सकते हो कि यहाँ पर मैं जुपिटर नोटबुक स्पेस देकर लिखूंगा। मैंने लिखा जुपिटर स्पेस नोटबुक और एंटर। और जैसे मैं एंटर मारूंगा, आप देखो यहाँ पर कि ये गूगल क्रोम में मुझे खोलने को बोल रहा है। तो मैं क्या करूँगा, मैं इसको बोलूँगा ऑलवेज ओपन इन गूगल क्रोम। और यहाँ पर ये देखो मेरी जुपिटर नोटबुक खुल चुकी है। तो ये पेज आपको देखने को मिलता है। यहाँ पर मैं एक नई नोटबुक बना सकता हूँ। तो मैं न्यू पे क्लिक करूँगा, पाइथन 3 पर क्लिक करूँगा और मेरे लिए एक नई नोटबुक बन गई है। इस नोटबुक को रीनेम करने के लिए मैं यहाँ पर डबल क्लिक करूँगा और इसका नाम रखूँगा फर्स्ट नोटबुक। कुछ इस तरह से। नोटबुक क्या होता है जुपिटर में? नोटबुक क्या होता है? नोटबुक के अंदर कोड होता है, इन्फॉर्मेशन होती है। किस तरह का कोड और इन्फॉर्मेशन हम लोग डाल सकते हैं, ये मैं आप लोगों को बताता हूँ। लेकिन उससे पहले मैं आप लोगों को दिखाना चाहूँगा कि जिस फोल्डर में हम लोग काम कर रहे हैं ना, उसमें हमने एक फर्स्ट notebook.ipynb नाम की एक फाइल बनाई है। IPYNB मतलब IPython नोटबुक। ये एक एक्सटेंशन होती है जो कि जुपिटर नोटबुक्स की एक्सटेंशन होती है। जैसे कि TXT होती है, टेक्स्ट फाइल्स की एक्सटेंशन। जैसे कि PDF होती है, PDF फाइल्स की एक्सटेंशन। उसी तरह से IPYNB IPython नोटबुक की एक्सटेंशन होती है। ये IPython क्या होता है? IPython इंटरैक्टिव कंप्यूटिंग करने के लिए कमांड शेल होता है, जो कि हम जुपिटर नोटबुक में यूज़ करते हैं। तो यहाँ पर आप लोग देखो कि जैसे मैंने जुपिटर नोटबुक लिखा, तो इसने यहाँ पर मुझे नोटबुक बनाकर दे दी और इसने मुझे एक लिंक दे दिया और लिंक के साथ एक टोकन भी दिया, जिसको मैं इस नेटवर्क में यूज़ कर सकता हूँ। अब क्योंकि एक्सटेंशन होती है जो कि जुपिटर नोटबुक्स की एक्सटेंशन होती है। जैसे कि TXT होती है, टेक्स्ट फाइल्स की एक्सटेंशन। जैसे कि PDF होती है, PDF फाइल्स की एक्सटेंशन। उसी तरह से IPYNB बेसिकली IPython नोटबुक की एक्सटेंशन होती है। ये IPython क्या होता है? IPython इंटरैक्टिव कंप्यूटिंग करने के लिए कमांड शेल होता है, जो कि हम जुपिटर नोटबुक में यूज करते हैं। तो यहाँ पर आप लोग देखोगे, जैसे मैंने जुपिटर नोटबुक लिखा तो इसने यहाँ पर मुझे नोटबुक बनाकर दे दी और इसने मुझे एक लिंक दे दिया और लिंक के साथ एक टोकन भी दिया, जिसको मैं इस नेटवर्क में यूज कर सकता हूँ। अब क्योंकि मैं इसको अपने कंप्यूटर में रन कर रहा हूँ तो मुझे नेटवर्क में इसको यूज करने की जरूरत नहीं है, और आप लोग भी टेंशन मत लेना इस बात की कि नेटवर्क में यूज करने का क्या मतलब है। अब आप देखोगे मैं इस फोल्डर में आऊंगा ना, तो आप देखो यहाँ पर फर्स्ट नोटबुक डॉट IPynb ऑटोमेटिकली बन गया मेरे बुक्स प्रोजेक्ट में। इसका मतलब कि जो भी फाइल्स मैं यहाँ पर बनाऊंगा वो यहाँ भी बन जाएंगी। हाँ दैट्स ट्रू, यहाँ पर भी बन जाएंगी। क्या इसका मतलब ये हुआ, जो भी चेंजेस मैं यहाँ पर करूंगा वो चेंजेस यहाँ पर भी इस फाइल में हो जाएंगे? हाँ बिल्कुल हो जाएंगे, क्योंकि यही तो फाइल है जिसको हम एडिट कर रहे हैं यूजिंग जुपिटर नोटबुक। बहुत बढ़िया। लेकिन ये क्या है इन, और मैं कैसे यहाँ पर पाइथन कोड चलाऊँ? तो मैं आपको बताऊंगा। आप यहाँ पर लिखते हो प्रिंट और इसके बाद आप लिखते हो हेलो वर्ल्ड। हेलो वर्ल्ड आपने लिखा यहाँ पर, और इसको अगर आपको रन करना है कंट्रोल प्लस एंटर मारो और इसका आउटपुट आपको यहाँ पर मिलेगा। अब अगर आप लोग एक नया सेलेक्ट करना चाहते हो तो आप यहाँ पर प्लस पर क्लिक कर सकते हो और एक नया सेलेक्ट हो गया, जैसे कि आप यहाँ पर देख सकते हो। ठीक है, अब यहाँ पर अगर आप चाहते हो कि यहाँ पर आप कोड नहीं लिखना चाहते, आप मार्कडाउन लिखना चाहते हो, तो आप यहाँ पर मार्कडाउन भी लिख सकते हो। अगर आप चाहते हो यहाँ पर एक हेडिंग है, जैसे मान लो मैं चाहता हूँ कि यहाँ पर मैं लिखना चाहता हूँ कुछ इस तरह से, मैं यहाँ पर इसको ओके लिख देता हूँ और मैं यहाँ पर लिखता हूँ, लेट्स से मैं लिखता हूँ पाइथन ट्यूटोरियल। मान लो मैं इस नोटबुक के अंदर पाइथन ट्यूटोरियल लिखना चाहता हूँ, कंट्रोल एंटर मारूंगा, ये ऐसा दिखेगा। फिर मैं यहाँ पर प्लस पर क्लिक करूंगा और यहाँ पर मान लो मैं लिखना चाहता हूँ पाइथन इज एन ऑब्जेक्ट इज अ जनरल पर्पस ऑब्जेक्ट ओरिएंटेड प्रोग्रामिंग लैंग्वेज। मान लो मैं लिखना चाहता हूँ तो मैं चाहूंगा कि मैं मार्कडाउन में लिखूँ कुछ इस तरह से, और मैं जैसे कंट्रोल एंटर मारूंगा ये कुछ इस तरह से दिखेगा। मैं यहाँ पर मार्कडाउन सिंटेक्स का इस्तेमाल कर सकता हूँ। अगर आपको मार्कडाउन सिंटेक्स नहीं पता क्या होता है तो मार्कडाउन आप लोग यूज कर सकते हैं pretty much चीज़ों को स्टाइल करने के लिए। जैसे कि आप कुछ ऐसे लिख सकते हैं इट्स अमेजिंग, और आप कुछ ऐसे लिख सकते हैं इट्स वंडरफुल। कंट्रोल एंटर मारेंगे ऐसे दिखेगा, बुलेट पॉइंट्स बन गए। मार्कडाउन सिंटेक्स बहुत ही इजी है, आप लोग सीख सकते हैं अगर चाहें तो, बट मार्कडाउन सिंटेक्स पे ज़्यादा टाइम मत लगाना। आप एक सिंगल हैश लगाकर एक हेडिंग लिख सकते हैं, डबल हैश लगाकर H2 लिख सकते हैं, जैसे कि मैं आपको दिखाता हूँ। यहाँ पर अगर मैं डबल हैश लगाकर लिखूंगा लेट्स लर्न और मैं कंट्रोल एंटर मारूंगा तो आप देखो ये लेट्स लर्न थोड़ा छोटा दिखेगा हमारी मेन हेडिंग से। ठीक है, तो ये हमारी H1 हो गई जिसको हमने एक हैश लगाकर लिखा था। 2 हैश लगा देंगे तो क्या होगा कि लेट्स लर्न यहाँ पर कुछ इस तरह से आ जाएगा, थोड़ा सा छोटा। 3 हैश लगा देंगे तो थोड़ा सा और छोटा हो जाएगा।
How to mark that? One second, I will see it.
कैसे लिख सकते हैं इट्स अमेजिंग, और आपको कैसे लिख सकते हैं इट्स वंडरफुल। कंट्रोल एंटर मारेंगे ऐसे दिखेगा, बुलेट पॉइंट्स बन गए। मार्कडाउन सिंटेक्स बहुत ही इजी है, आप लोग सीख सकते हैं अगर चाहें तो, बट मार्कडाउन सिंटेक्स पे ज़्यादा टाइम मत लगाना। आप एक सिंगल हैश लगाकर एक हेडिंग लिख सकते हैं, डबल हैश लगाकर H2 लिख सकते हैं, जैसे कि मैं आपको दिखाता हूँ। यहाँ पर अगर मैं डबल हैश लगाकर लिखूंगा लेट्स लर्न और मैं कंट्रोल एंटर मारूंगा तो आप देखो ये लेट्स लर्न थोड़ा छोटा दिखेगा हमारी मेन हेडिंग से। ठीक है, तो ये हमारी H1 हो गई जिसको हमने एक हैश लगाकर लिखा था। 2 हैश लगा देंगे तो क्या होगा कि
One second, why is not
डाउन में लिखूँ कुछ इस तरह से, और मैं जैसे कंट्रोल एंटर मारूंगा ये कुछ इस तरह से दिखेगा। मैं यहाँ पर मार्कडाउन सिंटेक्स का इस्तेमाल कर सकता हूँ। अगर आपको मार्कडाउन सिंटेक्स नहीं पता क्या होता है तो मार्कडाउन आप लोग यूज कर सकते हैं pretty much चीज़ों को स्टाइल करने के लिए। जैसे कि आप कुछ ऐसे लिख सकते हैं इट्स अमेजिंग, और आप कुछ ऐसे लिख सकते हैं इट्स वंडरफुल। कंट्रोल एंटर मारेंगे ऐसे दिखेगा, बुलेट पॉइंट्स बन गए। मार्कडाउन सिंटेक्स बहुत ही इजी है, आप लोग सीख सकते हैं अगर चाहें तो, बट मार्कडाउन सिंटेक्स पे ज़्यादा टाइम मत लगाना। आप एक सिंगल हैश लगाकर एक हेडिंग लिख सकते हैं, डबल हैश लगाकर H2 लिख सकते हैं, जैसे कि मैं आपको दिखाता हूँ। यहाँ पर अगर मैं डबल हैश लगाकर लिखूंगा लेट्स लर्न और मैं कंट्रोल एंटर मारूंगा
one second, how it
तो
done?
कुछ इस तरह से, और मैं जैसे कंट्रोल एंटर मारूंगा ये कुछ इस तरह से दिखेगा। मैं यहाँ पर मार्कडाउन सिंटेक्स का इस्तेमाल कर सकता हूँ। अगर आपको मार्कडाउन सिंटेक्स नहीं पता क्या होता है तो मार्कडाउन आप लोग यूज कर सकते हैं pretty much चीज़ों को स्टाइल करने के लिए। जैसे कि आप कुछ ऐसे लिख सकते हैं इट्स अमेजिंग, और आप कुछ ऐसे लिख सकते हैं इट्स वंडरफुल। कंट्रोल एंटर मारेंगे ऐसे दिखेगा, बुलेट पॉइंट्स बन गए। मार्कडाउन सिंटेक्स बहुत ही इजी है, आप लोग सीख सकते हैं अगर चाहें तो, बट मार्कडाउन सिंटेक्स पे ज़्यादा टाइम मत लगाना। आप एक सिंगल हैश लगाकर एक हेडिंग लिख सकते हैं, डबल हैश लगाकर H2 लिख सकते हैं, जैसे कि मैं आपको दिखाता हूँ। यहाँ पर अगर मैं डबल हैश लगाकर लिखूंगा लेट्स लर्न और मैं कंट्रोल एंटर मारूंगा तो आप देखो ये लेट्स लर्न थोड़ा छोटा दिखेगा हमारी मेन हेडिंग से। ठीक है, तो ये हमारी H1 हो गई जिसको हमने एक हैश लगाकर लिखा था। 2 हैश लगा देंगे तो क्या होगा कि लेट्स लर्न यहाँ पर कुछ इस तरह से आ जाएगा, थोड़ा सा छोटा। 3 हैश लगा देंगे तो थोड़ा सा और छोटा हो जाएगा। तो मार्कडाउन सिंटेक्स हम लोग लिख सकते हैं विद इन अ नोटबुक। तो आई होप कि ये चीज़ तो समझ में आ गई आप लोगों को। अब ये सब करने का फायदा क्या है? जैसे मान लो मैंने ये ट्यूटोरियल लिख दिया, इसके बाद मैं अगला सेल डालना चाहता हूँ एक कोड, मैं दिखाना चाहता हूँ कि अगर मैंने A=5 किया, कंट्रोल एंटर मारा, फिर इसके बाद मान लो मैंने एक और सेल यहाँ पर डाला, मैंने लिखा B= मान लो 8 और मैंने कंट्रोल एंटर मारा, और इसके बाद मान लो मैंने एक और सेल यहाँ पर लिखकर A+B लिख दिया और कंट्रोल एंटर मारा तो ये आउटपुट इसका ऑटोमेटिकली यहाँ पर 13 आ जाएगा। ठीक है, तो ये करने का फायदा क्या हुआ? हमारे ये जो वेरिएबल्स हैं ये मेमोरी में लोड होते जा रहे हैं, और फिर हमें कभी भी यूज़ करना है तो हम नीचे टुकड़ों में अपने प्रोग्राम को रन कर सकते हैं। एक सबसे बड़ा फायदा ये होता है, और डेटा साइंस में हमें टुकड़ों में प्रोग्राम को रन करना पड़ता है। अब ये सब पॉसिबल कैसे हो पाता है? जो IPython है ये सब हमारे लिए पॉसिबल बनाता है। एक कर्नल रन होता है, अगर मैं चाहता हूँ कि सारे सेल्स मेरे ऊपर से नीचे तक रन हो जाए तो मैं ऑर्डर में उनको रन कर सकता हूँ, लेकिन मैं ये भी कर सकता हूँ कि अगर मैं चाहता हूँ कि बीच में मैं अचानक से ये वाला
Okay, I will continue after some Unity lecture. It's really very interesting, but I have to complete this first. Okay, so I just open that script. Something is going. Yeah. I open the script. 1 second, I have to open it again. Something is going fishy. It's not opening, I don't know. Previously it was opening, but now startly. No, now it's clear. Okay.
This will enable you to access the code and functions in the input system namespace in this script. The player input component will notify the player controller script of action happening by calling functions with predefined names within your scripts. For example, to create the rollerball game, you need to be notified whenever the move action happens. The predefined function for the changes in movement controls when pressing WASD or moving a joystick on a controller is called onMove. In that function, the computer will read the value of the input, for example, up, down, left, or right, and then use that information to move the ball using code in the update function, which you'll write later. Let's write an onMove function. The first thing you need to do is write a function declaration, which tells the computer to create a function. Below the start function, but before the final curly brace, add a new line. Write void onMove, open and closed brackets. Void means that this function won't return any values. Next, add an open curly brace, leave a line, and then add a closed curly brace. The space inside the braces is called the function body, and this is where you add instructions for the computer to complete. These instructions are specifically for the function onMove. Each function has its own set of curly braces. Okay, what's next? The player input component will be sending data of type input value to your script. So you need to add this to the function's input parameters. These are variables which will be used to store and reference data for the function. Inside the parentheses in your function call, add input value, movement value.
I have to.
Movement value is the name of the variable you will use within the function. Input value is the type of variable. Variables can have different data types, which means they store different types of data. The movement of the rollerball sphere will be captured in two directions, up and down, and left and right. In other words, the movement value variable will capture and store the data from the x direction and the y direction of input devices. This kind of data can be stored as a vector2 variable. In the next video, you'll create that variable and then start to apply the data to the player sphere.
Oh, really? Apply input data to the player. Now that's what we have done. Now we are going to apply some input data for the player, to the player.
In the last video, you wrote a declaration for the onMove function. Next, let's use the method get to get movement input data from the sphere and store it as a vector2 variable. In the space inside the onMove function, add the line vector2 movement vector equals movement value dot get open angle bracket vector2 closed angle bracket open and closed brackets
It's really great.
semicolon.
It's the feature of
This code takes or gets the vector2 data from the movement value and stores it in a vector2 variable you are creating called movement vector. The player game object uses a rigid body and interacts with a physics engine. Next, you need to use the variable you just created to add or apply forces to the rigid body and move the player game object in the scene. To do this, your player controller script will need to access the rigid body component and add force to the player game object. First, let's create a variable to hold the reference in the script. Above the start function, add the following code: private rigid body RB semicolon. This will create a private variable of the type of rigid body and call that variable RB. This will hold a reference to the rigid body you need to access. The variable is private and not public because you don't need this variable to be accessible from the inspector or from other scripts right now.
Yeah.
Next, inside the start function, write RB equals get component, open angle bracket, rigid body, closed angle bracket, open and closed brackets,
Power of
semicolon.
God.
This sets the value of the variable RB by getting a reference to the rigid body component attached to the player sphere game object.
Yeah.
There is definitely a rigid body component attached to the game object because you added that component earlier. All of the code in the start function is called on the first frame that the script is active. This is often the very first frame of the game, so the player will be able to move the sphere straight away. Now you need to set up the fixed update function so you can call add force on the rigid body stored in the variable RB. First, create a new function called fixed update below the start function, and just like that function, the type should be void because it will perform a task and not return any values, and there should be no parameters in the parentheses. You'll learn more about the uses of the void type with functions as you continue your programming learning journey. Remember to add a set of curly braces beneath the function declaration. This is where you'll add your code. Excellent. In the next video, you'll add force to the player game object's rigid body.
Okay, thank you so much. Hope you are enjoying the lectures. It's really very interesting to make games, and it's a good journey of a game developer. One day maybe I will be a great game developer. I'll be void fix up. Okay, fine. This is cool. Apply force to the player.
Next, let's start to write the code for adding force. In the function body, add the code rb.addForce. Inside open and closed brackets, type movement vector, and then end that line with a semicolon. You'll probably see in your script editor that there is an error on this line. There are two reasons for this. Firstly, the variable you are trying to use is a vector2, and you need to give this method a vector3 variable. Vector3 variables store data across 3 axes, x, y, and z. These values will determine the direction of the force you add to the ball. If you head back to the editor and look at the global gizmo, you can see the arrows also indicate this. To resolve this issue, you need to create 2 new variables for the individual input directions. Underneath the rigid body variable you created, add 2 more variables called movement x and movement y. These should be private, like the previous variable, float type, which is short for floating point, or decimal point value. These give you more precision than a whole number or integer value. You can then reference these values inside of onMove and assign these values of movement vectors x and y. In onMove, add the following 2 lines of code. Movement x equals movement vector.x, semicolon. Movement y equals movement vector.y, semicolon. Excellent. The second reason you were getting an error is because the movement vector variable was created inside of onMove. That means it's what's called non-existent in the current context, as it was inside another method. To fix this, you can combine the movement floats you just created inside of fixed update to create a vector3 variable. This will take 0 as the y value, because the ball needs to move along the x and z axis in 3D space. In the fixed update function, add a new line at the top of the function and write vector3 movement equals new vector3, open brackets, movement x, comma, 0.0f, comma, movement y, close brackets, and then a semicolon. The f after the value signifies that this is a float value.
Yeah.
Next, use the new vector3 variable, movement, to add force to the rigid body of the player sphere. Revise the second line of code in fixed update to rb.addForce, open brackets, movement, close brackets, semicolon. Let's save the script and then return to the Unity editor to give it a try. Use the play button to enter play mode and test. It works, but the player is moving really slowly.
Okay, let's see how is moving. Let's see.
Leave play mode to stop testing.
Okay, one second. Let me check it. Scripts are compiling. Expected. Okay, some semicolon is expected. 1 second. This is previous error. Now it's gone. Control S. C102 expected. Oh, here it's expected. Let's save it. Inside now it's not just input value 17.
In the next video, you'll adjust the script to fix. Use the play add force. Open brackets, movement, close brackets, semicolon.
Oh, sure. Moment is here, not movement vector, it's movement. Only movement. Yeah. That's fine. Okay. Save it. Input value could not be found. Are you missing? Where is the input value? Can you check out where the input value?
Let's save the script. Is that this is a private, like the
Input system should be there, no? There is no input system. Now you have to put input system there. That's why it's getting error. Input engine, first input engine already there. Next input in Unity engine, no, Unity engine, input system. That's the error you have to resolve. Now it will resolve. Let's compile.
the previous variable, float type, which is short as it was inside another method. To fix this, movement x, comma, 0.0f, comma, movement y, close brackets, and then a semicolon.
So resolve. Now you can play it.
The f after the value signifies that this is a float value. Next, and return to the Unity editor to give it a try. Use the play button to enter play mode and test. It works, but the player is moving really slowly.
You can see it's moving, but it's very slow.
Leave play mode to stop testing. In the next video, you'll adjust the script to fix this.
It's moving, but very slowly. You can't identify. It's moving very slowly, very slowly. It's moving. As you can see, the script. Yeah, I think this is movement vector, not movement. Okay, again the same error is coming. The same movement is not movement vector. It's not moving, no. That's the issue.
Next video, you'll adjust the script to fix this. script and then return
1 second, I check out the whole script. Here's movement, vector 3 movement is there, new vector this, okay. No, that's okay, totally okay.
to the Unity editor to give it a try. Use the play button to enter play mode and test. It works, but the player is moving really slowly. Leave play mode to stop testing. In the next video, you'll adjust the script to fix this.
Why not saying if they're moving? I don't know. Some movement is there, totally. Some movement is there. I'm not ignoring, but just very, very, very small. I'm not able to notice it. Okay, complete. Okay, with the movement speed for the video.
Okay, you've almost finished setting up the player movement, but the speed isn't quite right. Let's go back to your script editor to fix that. First, let's add a speed variable to the script so that you can control the player movement from inside the inspector. Go to the start of the script where you have declared other variables. Add a public float variable called speed to the start of the script with a starting value of 0. To do this, write public float speed equals 0, semicolon. Next, back in fixed update, multiply the force you are adding to the sphere's rigid body by this strength variable. Back in fixed update, multiply the force you are adding to the sphere's rigid body by this strength variable. To do this, revise your line of code to rb.addForce, open brackets, movement times speed, close brackets, semicolon. Then save your script and return to the editor. Because you made the speed variable public, you can find it in the inspector on the player controller script component.
Okay, let's see where it is. Okay, let me see. Some rolling is there. When you go player, and here you can see, where is that? Ah, yeah, here you can see the speed. Let's play it again.
Let's try changing the variable's value to 10 to see if the speed
Okay, let's try to run it with normal speed. It's moving, it's moving. Now I have to change it to, oh, it's moved. You can see it's moved totally. I had to stop it, it's moving. Let's use it 5, okay. Okay, going forward, coming inward. It's really amazing. Really amazing.
speed is fast enough to improve the player experience. Enter play mode and test the revised movement. Great, this looks like a good speed for the player. And the value is now exposed, so you can adjust it easily from the Unity editor if you need to. Exit play mode, and then save your changes to the scene. Congratulations, the player can now move the sphere. In the next section of this project, you'll explore how to set up the camera for your game.
It's really a great, good thing to do. Oh, it's really good. So really easy to do. You can see this type of object. Final script sample. You can see the final script. This is the final script. And if you want to just copy it, you can just select it, the whole script. But I don't want to copy. If you want, you can copy it and use it as yours. But I want to keep my own script. It's better to write your own script without any copying. You will learn more. Okay. Mark as complete. Clear instructions are given and I'm following that. Engaging instructor is there. Very good. Continue the next. Now moving the camera. See the camera position. The camera look at something. The camera will move with this. Okay. Set the camera position. Okay, raise and rotate the camera. Select the main camera and hurricane.
So right now, the camera doesn't move.
The camera was not moving, as you've seen already. As I play the play button, it was not moving.
And from its current position, can't see a lot.
You can't see a lot.
To change this, you need to tie the camera to the player game object. First, set the position of the camera.
But you can't see from
Lift it up by 10 units.
1 second. I have to lift it by 10 units. Select the camera. Lift it by 10 units. Upper side. Next.
Tilt it down by 45 degrees.
45 degrees.
This is a typical third-person setup, with the camera as a child of the player game object. This works well for a lot of games, because the camera game object will inherit the transform changes of the player game object. When the player moves in the game, the camera will move with them. However, for this game, that setup creates a problem. When the player rotates, the camera rotates as well. Because the ball is rolling, the camera is also going to inherit this motion. Let's look at this in play mode.
1 second. How she did? Let me check it.
Moves in the game, the camera degrees. This is a typical third-person setup, with the camera as a child of the player game object. This works well for a lot of games, because the camera game object will inherit the transform changes of the player game object. When the player moves in the game, the camera will move with them. However, for this game, that setup creates a problem. When the player rotates, the camera rotates as well. Because the ball is rolling, the camera is also going to inherit this motion.
Okay.
Let's look at this in play mode.
Okay, let's play.
Hold down the up arrow to move. The camera is a child of the player's sphere. So even though the camera is not moving at all relative to the player's game object, you can see that the player game object is rotating wildly and the camera's point of view rotates with it. Okay, let's exit play mode. Let's think about how to resolve this. The player game object in your game, a sphere, is rotating on all 3 axes, not just one. In a more typical third-person game camera setup, the camera, as a child of the player game object, will always be in a position relative to its immediate parent. This position will be the parent's position in the game, modified or offset by any value in the child's transform. In this game, that approach won't work, so let's detach the camera. The new offset value will be the difference between the player game object and the camera. To do this, you need to associate the camera with the player game object with a script rather than as a child of the game object. In the next video, you'll write that script.
Main camera is player. Okay. Main cameras and there's a game inside game object. Then it was moving together, but we don't want this one. So we will write script, as you can see. and gone away. And again. So you could see this. Camera controller script I have to write for this video.
Okay, let's start by creating the new script to control the camera. With the main camera game object selected in the hierarchy, select Add Component. In the inspector, call your new script Camera Controller.
Okay, I have to add new script. First thing is that I will put here.
If you use the inspector to Okay, let's start by creating the new script to control the camera. With the main camera game object selected in the hierarchy, select Add Component.
Okay, I have to select the add component of it.
In the inspector, call your new script Camera Controller.
Camera controller I have to write. Camera controller. Okay, this is the next script. Create and add. Save it.
If you use the inspector to create the script, it will be placed in the root or top level of the project folders. Move it to your scripts folder. Open the new script for editing.
It's already just in the script folder. Now open it.
This script needs two variables: a public game object reference to the player game object, and a private vector3 variable to hold the offset value. Inside the first curly brace, add the following line: public game object player, semicolon. This will reference the player game object's position. On a new line underneath, add another variable declaration: private vector3 offset, semicolon. This will store the offset value. The offset value variable is private because you're going to set the value in the script. Now that you've declared the variable, let's calculate it. To do this, you're going to take the current transform position of the camera game object and subtract the transform position of the player game object to find the difference between the two.
Okay.
The start function is the best place for this code. It needs to be calculated immediately when the game starts, but it only needs to be calculated once. In the start function, on a new line after the first curly brace, let's write the equation like this: offset equals transform dot position
Why in here? I can also put in the
minus player dot transform dot position semicolon. This will set offset equal to the camera transform position minus the player game object's transform position. Next, you're going to use that to set the camera game object's transform position. This needs to happen every frame, so the best place for that code is the update function. Inside the first curly brace, write transform dot position equals player dot transform dot position plus offset semicolon. Now when a player moves the sphere with controls on the keyboard, the frame before displaying the camera game object is moved into a new position aligned with the player game object before the frame is displayed. This is just like what would happen if it were a child of that object, except it's only matching the position and not the rotation of the sphere. However, update is not actually the best place for this code. It is true that update runs every frame, and in update, each frame you can track the position of the player game object and set the position of the camera. However, you don't control which order all of the update functions happen. That means that the update could run before other scripts or Unity systems that will change the player position, like the physics system. So what's the solution? Well, for follow cameras and tasks like gathering last known states, it's best to use late update. Late update runs every frame, just like update, but will run after all of the other updates are done. Add late in front of the update method to change this. Okay, brilliant. Now you know that the camera position won't be set until the player has moved for that frame. Let's save the script and return to Unity to test it out.
Okay, thank you. Let update. Let's check out in that. Save it or save it. Check out the main camera. By here is there. And put the player here. Now save it. Game object player, so it was played there. Offset you can see. Okay, I understood. Fine. Reference to the player.
There's one thing that you need to do before testing your changes. Create a reference to the player game object. To do that, drag the player game object from the hierarchy into the player slot in the camera controller component. Now enter play mode to test what you've done. The camera follows the rolling ball without rotating, even as the ball goes over the edge. Excellent. Remember to exit play mode when you finish testing and save your Unity project. Now that you've set up the camera, in the next section of this project, you'll configure the basic play area for the game.
Okay, that's all. Now you can see it will work without that. So, it's working now. Now it's working. The camera is with it, and you can see it's gone, and again it will come. Camera is also going good. Oh, finally, this is working. You have to press it, select it, and just drag and drop here, as you can see, as I was doing. Okay, drag and drop here. Yes. Okay. You can test it. Mark it. This is the final script sample. You can copy and paste it. And it's over. Thank you so much for watching it. I will mark it star. The instruction is good. Continue. Okay, setting up the play area. Okay. This thing we will do in this. We will create and configure one wall, duplicate it and place it to create a content game area. Okay, this thing we will do. We will create a wall for the play field. For the video, I am going to follow this video.
Okay, let's set up the playfield. The playfield for your game will be very simple. You will place walls around the edges to keep the player game object from falling off. And you'll create and place a set of collectible objects for the player to pick up. First, let's get organised. In the hierarchy, create a new empty game object. Reset its transform and then rename it Walls. This will be the parent game object for all of the wall game objects. Now you can build some walls. Let's start by creating a new cube to be the first wall. In the hierarchy, select Create, 3D Object, Cube. Rename the cube game object West wall. In the inspector, right-click the transform component title and select Reset. This resets the component.
Reset it. Now F it. F. This is the wall.
To its default values. Now drag the west wall game object onto the walls game object and release.
Yes, now it's the
This makes west wall the child of walls.
walls.
Let's focus the scene view camera to the west wall object. To do this, press the F key while the cursor is over the scene view, or select Edit, Frame Selected. Next, you need to change the size of the cube to fit one side of the play area. In the inspector, change the cube's transform scale X value to 0.5, Y value to 2, and Z value to 20.5. You can push the wall into place using the Translate tool, or you could enter a transform position value in the inspector. Let's use the inspector.
Now it's totally
Set the transform's position X value to -10. This places the wall neatly to the edge of the play area. Now just one more thing. Let's create a new material to change the colour of the wall. In the project window, go to the Materials folder and select Create Material. Rename this new material Walls.
One second. Let me do.
In the project window, go to the Materials folder and select Create Material.
Materials even on.
Rename this new material Walls.
One second. Let me check out how it's looking. Is it looking good or not? Now it's looking good. Some part is under also. It's okay. Under maybe go. Yeah. Materials. No. Now I will create new material. Walls.
In the inspector, select the base map's colour field to open a colour picker. Set the RGB values to 79, 79, and 79. Next, set the metallic to 0 and change the smoothness to 0.25 from matte finish. Then, drag the material from the project window onto west wall in the scene view. Great! Now you've done one wall. In the next video, you'll complete the play area.
Yeah. So that's one wall, west wall I have already done. Now it's time to do another walls and make a complete boundary of the game. You can see the wall here. When I press F, you can see it very more clearly. So you can see it. And it's the play field wall. Okay.
To create the next wall, you could start with another new cube, but then you'd have to rescale the new cube before placing it. Your first wall is already a perfect size. Right-click the west wall game object and select Duplicate. Rename the new game object East Wall. To place the wall, just remove the negative sign on the position X value of the transform component. Then it will move into place on the east side of your game area. Now, let's duplicate the east wall and rename the duplicate North Wall. Reset the north wall's position X value to 0.
One second.
The new game object, East Wall. To place the wall, just remove the negative sign on the position X value of the
No, just remove it because west is -10, then east will be +10. It's the opposite of that. So you can remove it and it will definitely come at the opposite of it, as you can see at that side. And when you press F, you can see also here. This is the wall of the east wall. This is the east wall.
transform component. Then it will move into place on the east side of your game area. Now, let's duplicate the east wall and rename the duplicate North Wall. Reset the
Now again, east wall I will duplicate and put it north wall. North wall, okay.
the north wall's position x value to 0, so it moves to the centre of the play area. You now have two choices. You can either rotate the wall by 90 degrees around the y-axis, or, as this is a cuboid, you can scale the wall using 20.5 in the x-axis and 0.5 in the z-axis scale values.
Opposite.
Now the game object is scaled correctly for its orientation as the north wall. Awesome!
Not
You can drag the wall into place by hand.
1 second. 0.5. There should be some size now. 0.5.
Or set the north wall's transform z-axis position to 10 to
1 second. 1 second. Where is the north wall? 2.5 to 0.5. Okay. North wall is this. So much space is there. Now it's good. I'm not able to put it. 1 second.
place it. Next, duplicate north wall and rename it south wall.
Okay. Ready.
Set the transform z-axis
1 second. I am not able to see.
as the north wall. Awesome!
Also be 0.
You can drag the wall into place by hand, or set the north wall's transform z-axis position to 10 to place it. Next, duplicate north wall and rename it south wall.
I will change this. 1 second. I already have check break, but still some issues. 0.5 to 20.5.
Set the transform z-axis position to -10 and it will move into place too. First, save your changes. Then let's enter play mode and test. Fantastic! The walls are exactly where they need to be and working properly as boundaries of the play area. Remember, it's important to test early and often to catch errors.
I think I should make it little more. The more. Where it is -15. Now it's looking good. Now it's totally good. Okay, but if you want to change it, you can also change it also. Looking good, but it's totally amazing. But I will change because it's very small ground. But it's okay. It's normal.
As soon as possible, where they need to be. Then let's enter play mode and test.
Okay, I will test it.
Fantastic! The walls are exactly where they need to be and working properly as boundaries of the play area. Remember, it's important to test early and often to catch errors as soon as possible.
Okay.
Let's exit play mode now. The walls are colliding with the player sphere because cube primitives come with a box collider component by default. This interacts with game objects with rigid body and collider components. If you're encountering issues with wall collisions, you may have accidentally enabled the isTrigger property on the collider component. This means the collider will be used to trigger events via script and won't be used for collisions. To fix this, disable the isTrigger property checkbox. You've now completed the playing area for your rollerball game. In the next part of this project, you'll create the pickup objects for the player to collect.
That's really working good. Really, I really impressed. Almost I have prepared that structure of that game. Now I will upgrade it more. Going to take some break. Play instruction. Creating collection. I will start after some break. 5-minute break. I am going to start. 5 minutes break. Okay. I'm going to stop it. Hello everyone. So I'm going to continue the lecture. Okay. Where is the lecture? This is okay. Minimize it. Okay. Creating collections. Okay. Now I'm going to create not collection, collectibles. Okay. All that collectibles that you saw at the first time. So in this tutorial, what we will do, we create a pickup game objects for the player to collect. We will write a script to rotate the collectible. So they will rotate and turn the pickup game object into a prefab. Initiate the prefab around your play area. That's what we will do. So we are going to create a pickup game object for the player to collect. Okay, let's start the video. As you can see here, and we'll write a script so that they can rotate, and we'll pick up every red. Okay. So we are creating a collectible game object pickup.
Let's get started creating objects for the player to collect. In the hierarchy, select Add, 3D Object, Cube. Rename the cube Pickup. In the Transform component, use the vertical ellipsis to reset the game object's transform to origin. Press F.
Cube, okay.
To focus the scene view Pickup. In the
Pickup session. Write it. Okay. Okay, this is the game object. Fine.
Transform component, use the vertical ellipsis to reset the game object's transform to origin. Press F to focus the scene view camera on the pickup cube. The player game object is currently overlapping the new cube, so select the move tool and drag pickup out of the way while you work on its functionality. The cube is currently buried in the plane, just like the player sphere was when you started this project. Remember that? The cube is also a regular shape, 1 by 1 by 1. So let's lift it up by half a unit, so that it rests on top of the plane. In the transform component for the pickup game object, set the position Y value to 0.5. This cube will be the collectible
1 second. Let's adjust the position. 3.47 of the pickup and Y to 0.5.
object in the game. To be effective, it needs to attract the attention of the player. So let's make the cube visually interesting. How about making it smaller? In the transform component, set each of the scale axis values to 0.5. This will give it the effect of floating above the play area. That will help identify this object as special. But perhaps that's not enough. Let's tilt it too. Set each of the rotation axis values to 45. The cube also needs to stand out more against the background walls and the player game object. Let's change its colour by creating another material. In the project window, find and select your first material, background. In the top menu, go to Edit, Duplicate. Rename the new material Pickup. With the Pickup material still
Okay, I have to make a new material. Just click on-
selected in the project window, use the colour picker in the
There are two pickups as a
inspector colour by creating another material. In the project window, find and select your first material, background. In the top menu, go to Edit, Duplicate. Set each of the rotation axis values to 45. The cube also needs to stand out more against the background walls and the player game object. Let's change its colour by creating another material. In the project window, find and select your first material, background. In the top menu, go to Edit, Duplicate. Rename the new material Pickup. With the Pickup material still selected in the project window, use the colour picker in the inspector to change its base map colour property. Let's make it yellow and use the RGB values 255, 200, and 0.
One second, let me do it. Let me do it by myself. Opaque is okay.
Now you can change the colour of the Pickup game object by changing its material on the mesh renderer component. Or by dragging the material from the project window onto the cube in the scene view. Now it's starting to look more like a pickup, but it's still very static. One thing that attracts attention of a user is movement. In the next video, you'll write a script to rotate the cube.
Something is not working properly. The color is not assigning. I'm not able to assign the color properly. Fine, next.
Okay, let's get that cube rotating. As you've done before, select the Pickup game object in the hierarchy, and then select Add Component, then New Script in the inspector. Call the new script Rotator, then select Create New Script in the inspector. Call the new script Rotator, then
Rotator is already there, no? Rotator is already there, okay. for this also. Okay, fine. And open it.
Select Create and Add to confirm. In the project window, move the rotator script to your scripts folder to keep things organized,
It's already there.
and then open the script to edit it. Once it's opened in your script editor, remove the start function from the template.
1 second, my friend is calling. I have to stop it because it may be recorded. Okay, ready to start the lecture. So I was here.
You won't be using forces to rotate the cube, so you can use update rather than using the fixed update function, so the rest is fine. Now, before you begin, let's think for a moment about what this script needs to do. It needs to make the pickup game object spin while the game is active. You have already set up the pickup game object's transform rotation property to 45, 45, and 45 for the X, Y, and Z axes. But these values don't change by themselves, and for the cube to spin, these values need to change every frame. To do this, you need to write a script that rotates the game object's transform. There are two main ways to affect the transform of a game object. These are translate and rotate. Translate moves the game object by its transform. Rotate rotates the game object by its transform. It has two possible initial parameters. One using a vector3 variable, and the other using 3 float values for x, y, and z. The simplest option is the vector3 parameter, which is all that's needed for this game. After the opening curly brace of the update function, add the following line of code. Transform dot rotate, open brackets, new vector3, open brackets again, 15, comma, 30, comma, 45, then 2 closed brackets, semicolon.
Okay, it's already there. It's already
Make sure that transform is a lowercase t, because you're referring to the component, not the variable type. This action also needs to be smooth and frame rate independent. To do this, multiply the vector3 value by time.delta time before the closing parentheses. Delta time is perfect for ensuring actions happen smoothly, because delta time is a float representing the difference in seconds since the last frame update occurred. It will dynamically change its value based on the length of a frame. Okay, that's all you need. Save this script and return to Unity. Let's enter play mode and test the script. Excellent. The pickup game object rotates. Exit play mode when you're done testing.
okay. I have 50, 30, 45. Time to do that. Now it's working. Now it's working. Oh, it's touching. It's touching. It's really good.
Remember to save your Unity project frequently.
I save it. Okay. Thank you so much. Fifteen 30 40 some network issues there. It's not working very greatly. I have to refresh it. Some network issues there. Okay, I just on the hotspot so I can use a personal network, internet net. Okay, now personal hotspot is on, so I have to connect it from here. Otherwise, it will be loss of steady. Okay, it's connected. I've done this. You can see the same thing I did.
Now you've created one rotating pickup collectible, it's time to place them around the play area. There's one vital step needed to do this. You need to make the pickup game object into a prefab. A prefab is an asset that contains a template or a blueprint of a game object or game object's family. Once a game object is turned into a prefab, you can use the prefab in any scene in your current project. By turning the pickup game object into a prefab, you will be able to make changes to a single instance of the prefab or to the prefab asset itself. And all of the pickup game objects in the game will be updated with those changes. So let's get started. First, go to the project window and check that you're at the root, or top level of the project. Make sure that no other item or directory is highlighted. Select Create, Folder, and rename this folder Prefabs. Now, select the pickup game object
Folder. Prefab folder. I already created prefabs or prefab. Prefabs. It's plural, not singular. Plural. Okay, prefabs.
in the hierarchy and drag it into the Prefabs folder. When you drag an item from the hierarchy into the project window,
One second, I have to make the prefab. Yes, and type it inside it. Now you can see prefab. They just duplicate. I don't like.
Unity creates a new prefab asset containing a template or a blueprint of the game object or game object family. Your game object will turn blue in the hierarchy when it becomes a prefab instance. Select the arrow to the right of the pickup prefab in the hierarchy to open the prefab edit mode. From this mode, you can use the arrow at the top of the hierarchy to return to a normal scene view. Now you've turned the pickup game object into a prefab. In the next video, you'll instantiate it around the play area for your players to collect.
Add more collectibles.
Okay, let's fill the play area with rotating pickup objects. Before you start, let's keep things organised. In the hierarchy, create a new game object and call it Pickup Parent. In the inspector, right-click the transform component title and select Reset to reset Pickup Parent to origin. Then, in the hierarchy, drag the pickup game object onto Pickup Parent. Next, make sure
Okay, fine.
that you have the child pickup game object selected in the hierarchy, not the parent. Select the gizmo in the upper right of the scene view to switch to a top-down view. Now, use your scroll wheel to zoom out a little so you can see the entire play area. Okay, let's start placing pickup objects. Move the first pickup game object somewhere you like. Next, let's duplicate the game object. Make sure it's selected and then go to Edit, Duplicate. You can use the hotkeys Ctrl-D for Windows or Command-D for macOS. Now place the second instance of the prefab. Using the hotkeys, create some more pickup game objects and place them around the play area.
Okay, I will do it. One second. Step by step, I will do it. 1 second.
About 12 is a good number for this game. To make this easier, you can move or Command-D for macOS. Now place the second instance of the prefab. Using the hotkeys, create some more pickup game objects
1 second. Where is that second one? 1 second.
and place them around the play area. About 12 is a good number for this game. To make this easier, you can move parallel to the ground or XZ plane by selecting the XZ plane at the center of the gizmo.
This is great.
Now place the second instance of the prefab. Using the hotkey,
6.29 second one. Oh, it's gone there. It's gone there. It's totally gone outside. Just pull it here. Okay, just pull it here, and then just carefully put here. Just pull side again. This is good. Now make it down. Now make duplicate of that, not that one. There should be equal gap. So check out the gap whether one sec. This is 0. Minus 0.26. Okay. For the gap of this 0.65. It should be one second. It should be same as z-axis. This is x or z-axis. It should be same y-axis or z-axis. Just like take care of it. Okay. Delete it. This is this one also. Some issues there. First change the not possible order. Okay. Some issues there. Let's see.
keys, create some more pickup game.
Test side is z-axis. It will go. You have to first change it to the world. Like this. One second. There is something here which will change it. Component. Something is way to go to it, but I don't know how. Always. Okay, fine. Layout is okay. Oh, now it's going. Thing is, again it will come there. Now it's okay. Left, not left. Put it. I want to see that coordinates. Okay, let's see the video again.
Objects and place them around the play area. About 12 is a good number for this game.
Let us see what is done.
Now place the second instance of the prefab. Pickup objects. Move the first pickup game object somewhere you like.
2D 3D. This
Ne-
has become no. This is not there. 2D 3D insane. Once should be there allowed. Defaults they are.
Next, let's duplicate the game object.
There is also one that is missing. I understand. There's some tool that is missing. See this. She is using 2D. Why is that 2D? I don't not able to see. That's the issue. Okay, fine. Let's see.
Make sure it's selected. Let's start placing Now, Next, make sure that you have the child pickup game object selected in the hierarchy, not the parent. Select the gizmo in the upper right of the scene view to switch to a top.
Okay, you can also switch from here also.
Down view.
Top down view. Okay, let's see the top down view. X or Z axis. This now selected, but now I want to select that coordinates, not that coordinates. The world coordinates. General.
Now, use your scroll wheel to zoom out a little so you can see the entire play area. Okay, let's start placing pickup objects.
Forty-five.
Move the first
अब इसको कैसे करूँ जिस तरह से कि यार कि वो वहाँ आ जाए, वही तो यार समझ में नहीं आ रहा। That's I'm not able to do. It's really very headache for it. Okay, let's see out. Let ChatGPT. Otherwise, it's very difficult to make. There's no option except ChatGPT. It's really very difficult for me. Look at the top toolbar of the scene. Okay. This is the scene. Find the global world axis and local objects on axis. Click it to switch mode. But there's no toggle bar. No, that's the issue. Where's the toggle bar? There's no toggle bar. If I on it also, still there's no toggle bar. There should be a toggle bar after scene. Maybe some issues there. Window layout. Still there is no toggle bar. Okay, 1 second. What? Find the toggle level. Global or okay, press X. This toggle between. Okay. This shortcut is good. Okay, press X. Now it's good. Thank you so much, ChatGPT. Otherwise, it takes a lot of time. ChatGPT is really great thing. You can use if you're stuck anywhere. Really, it's crazy thing. Common confusion 5%. Okay, you can use the ChatGPT here. Okay, finally. Okay, now thing is that I'm now using local. This is global. Oh, this is local. This is local. Okay, now I duplicate it and the axis here. From upside, I want to see. Okay, just put the y-axis. Okay, now it's good. Okay, just put here. Now put here. 0.5, 1.53. Okay, and duplicate. This is absolutely good. 3, 4.8, 0, 3, and 4.8. The space should be equalized, no? This should be 6, not 4.86. No, but this is very large. It should be 4. It should be 3. Or it should be. Only it should be 2. This should be 4. And the 0.505 is good. 0.005 is good. This is 3.58 minus 1. 1.5 minus 1. Speed should be. This is 3. This should be 3. Okay. This is 1.5. And this should be 0.
pick up game object somewhere you like. Next, let's duplicate the game object. Make sure it's selected and then go to Edit, Duplicate. You can use the hotkeys Control D for Windows or Command D for Mac.
Okay, I will do it. Okay, I will do it myself. It will be very enjoyable thing. Really, I love to do this. This fully geometrical thing.
OS. Now place the second instance of the prefab.
Okay, wait a second. My mom is calling, so I have to stop it. Okay, going to start. So I was there. I was just
Using the hotkeys, create some more pickup game objects and place them around the play area. About 12 is a good number for this game. To make this easier, you can move parallel to the ground or XZ plane by select.
I'm doing it. Okay, I'm doing it. Just wait a second. I'm doing it. I will complete it very soon. Duplicate it. But it will be very far. I have to be more near to it. 1, 2, 3. 1, 2, 3. It should be. I think this should be in the middle. Okay. 0, 0.53. Okay. Fine. Not 1.5. It should be. 1 second. 3. 1.5. Should be 1. Okay. Okay. Now 3 is going upward and 1 is going 2 times. Okay. This should be minus 1. And this should be 0, 3, and this should be 6. This should be here. But it will be again very again minus 4. Okay, fine. I just copy it and paste here. So the and have the rotation by it's roughly symmetric. I think it's almost symmetric, not totally. It's good. Proceed. Similarly, I could do this for it. No, it's good. Now looking great and good. It's not proper symmetric, but it's okay. For game, it should be some random. Okay.
Connecting the XZ plane at the center of the gizmo. Okay. That's
I think some project. Network issue is there. I should connect IDJ VLAN. Okay.
$12. At the moment, the collectible objects are present in the game, but the player can't actually collect them. That functionality is the next thing you're going to add.
12. One should be there. One more. 1, 2, 3, 4. Okay. How many are 1, 2, 3? One is missing. One not missing. Yeah, one more is missing. This should be here. This should be here. This should be here. One is missing. Okay. It's awfully crazy. Put somewhere. Put somewhere. Here. Somebody else. Somewhere else. This should be 12. Put here. This is a scene. No? Where is that? That's not coming. Center or that part is not coming. Okay, okay. This is missing. No, these are all off. Because of that, I'm not able to see what I was not seeing because of this reason. Nice cool. Now I can change to global to local or that thing. I want to drink water. Where is water? This. No, it's cool. But I think space here is more. Here the space is more. It should be not here. Here. Okay, fine. That's good. Start it. This should be on the ground. Why they are not on ground? I don't know. Should be on ground. So they are not on ground. ZX is 0. Okay. Y-axis is 0.5. Okay, understood. What are the ball? Is also in the okay. Then it will capture it. Don't worry about it. It will capture it. The same thing I was. But it is touching. But mine is not touching. Mine is upside. So you can see. Mine not touching. It will touch this one. It will also touch this one. I will touch this one. It's a little bit upside. Yeah. 0.0. ZX is 0. That I'm saying is 0. This is 0.5. 0. Ground is there is no, this will become totally useless. Don't do this. This becomes very. Let's see what the issue. But I think it's okay. This is a final skip or rotator. As I already done it. Okay, fine. Once again, let's see the overview again. This video again. So, once again. Yes.
Then, in the hierarchy, drag the pickup game object onto pickup parent. Next, make sure that you have the child pickup game object selected in the hierarchy, not the parent. Select the gizmo in the upper right of the scene view to switch to a top-down view. Now, use your scroll wheel to zoom out a little so you can see the entire play area.
Let's see this 3.5, 0.5, 0. This is the ratio of the pickup one.
Okay, let's start placing pickup objects. Move.
45 0.5, 0.5. Scale is, let's see the scale of 0.5, 0.5.
Move the first pickup game object somewhere you like. Next, let's duplicate the game object. Make sure it's selected and then go to Edit, Duplicate. You can use the hotkeys Control-D for Windows or Command-D for macOS. Now place the second instance of the prefab. Using the hotkeys, create some more pickup game objects and place them around the play area. About 12 is a good number for this game. To make this easier, you can move parallel to the ground or XZ plane by selecting the XZ plane at the center of the gizmo.
0, 0 is okay.
Okay, that's 12.
Okay, I think I should put 0 for all them. Now it's good. Now it's good. Now looking good. 0.000. Now I think now you can touch it.
At the moment, the collectible objects are present in the game, but the player can't actually collect them. That functionality is the next thing you're going to add.
Oh, now it's touching. Now it's really touching it. There, it's really amazing. Detecting collision and collectibles. Okay, we will revise our player control script to make pickup control disappear when they collide with. Okay, pickup game objects disappear when they collide with the player's player. Take pickup con. Okay, so this thing we will do. Tuck, 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 everything. Same.
Okay, what's next? Well, your players need to be able to collect the pickup game objects when the player game object collides with them. For this to happen, the game needs to detect the collisions between the player game object and the pickup game objects and use this information to trigger a new behavior. It's really important to test the collisions carefully. The pickup objects, the player's sphere, the ground plane, and the walls all have colliders. Without testing, the player might be able to collect and disable the wrong objects in the scene. For example, the ground plane. Let's get started. In the project window, go to the scripts folder and open the player controller script for editing. Before you begin writing the script, let's think about what the code needs to do. It needs to detect and test.
One second.
Collisions on the player's sphere collider. To do this, you're going to use the function onTriggerEnter. Imagine that you're playing a platform game, and you jump up to collect a perfect arch of coins, but bounce off every first one and fall back to the ground. That's not very elegant. The onTrigger function will detect the contact between the player game object and the pickup game objects without actually creating a physical collision. Let's start with the function declaration and parameters. Beneath the fixed update function, write void onTriggerEnter open brackets collider other closed brackets. Next, remember to add a set of curly braces to contain the function body. OnTriggerEnter will be called by Unity when the player game object first touches a trigger collider. It will be given a reference to the trigger collider that has been touched. This is the collider called Other. This reference gives you a way to identify the colliders that the sphere hits. You could destroy the game object that the trigger collider is attached to. However, in case you want to add additional functionality to the collectible objects later on, in this project, you'll only deactivate the game object rather than destroy it. So how can you deactivate the correct object, and in this case, the pickup game objects, using a script? Let's start to write the first line of code inside the function body for onTriggerEnter. You can address the other collider's game object through other.gameObject. To disable it, you need to use the method setActive. This method accepts a Boolean value inside the parentheses, that is, true or false. Use false to disable the game object. The full line should be other.gameObject.setActive, open brackets, false, closed brackets, semicolon. This code will disable game objects.
But thing is that no, this is collider is different. It's not. This if is not function to detect.
Correctly, but you don't have a way to filter which game objects the sphere can disable. In the next video, you'll use the Unity tag system to do just that.
Okay, fine. Okay, fine.
Now, you've written code to deactivate game objects that the player game object collides with. But this should only apply to the pickup game objects. The ground or walls disappearing would not be good. To do this, you're going to use the built-in Unity tag system. Tags allow you to identify a game object by comparing the tag value to a string. The first thing we need to do is set up the tag value for the pickup object back in the Unity editor. In the project window, go to the prefabs folder and select the pickup prefab. You can also use the arrow next to one of the prefab instances in the hierarchy. This opens prefab edit mode. In the tag list at the top of the inspector, there's a few pre-made tags, but there's nothing called pickup. Select
One second.
Add Tag. This
Let me do the same thing that he's doing. First go Unity pickup. Okay, again. Then untag, then I have select add tag. And add tag. This is
brings up the Tags and Layers panel with a list that's currently empty. To create a new custom tag, select the Add button to add a new row to the tag list. In the new empty element, which will be tag 0, type pickup. This is case sensitive, so be careful. It needs to be exactly the same string that you use in the script. You can close the Tags and Layers panel when you're done. Now you need to apply that tag to the prefab asset. Select the tag drop-down again. You should see that your new tag is now available in the list. Select this tag from the list. The asset is now tagged pickup. Use the arrow to leave prefab edit mode. And with the power of prefab, all the instances are also now tagged pickup as well. Great! Save your changes in the Unity editor before you return to the script. In the next video, you'll use this tag to make sure the sphere can only disable game objects with the pickup tag.
so as I see the Okay, write the script.
Now that you've created a pickup tag, you can use it to make sure the sphere only disables the correct game object. Let's do that using an if statement. This means that if a certain condition is met, the script will behave in a specified way. To create the if statement, you're going to use compare tag. Compare tag can compare the tag of any game object to a string value. At the top of the function body for onTriggerEnter, write if, open bracket, other
Already done it.
dot game object dot compare tag, open brackets,
Pickup. Already done it.
and in quotation marks, write pickup, and then close that statement with 2 closed brackets. This is the if statement. Be careful here. Comparison is case sensitive. Make sure to write the tag exactly as you did it in the Unity editor. Next, add a set of curly braces and cut and paste the line that reads other dot game object dot set active, open brackets, false, close brackets, semicolon. Now this code will be called every time the sphere game object touches a trigger collider. It will receive a reference for the collider that the sphere has hit and then check its tag. If it is a collectible object, the script will call setActiveFalse, which will deactivate the game object. Let's save this script and then return to the editor and enter play mode to test the game. So the tag is set correctly, but the sphere is still bouncing off the pickup cubes, just like we were bouncing off the walls. In the next video, you'll explore why this is happening and fix it.
Why is bouncing? Why is bouncing? I'm not able to see. I have to save first. Otherwise, it will not save the script. Okay, now wait for a while. Let's save it fast. Now run it. Ooh, it's bouncing, it's bouncing. I think it's bouncing. They're bouncing.
So, you created tags and used them to differentiate the pickup game objects. But when you tested the game, the sphere didn't disable them on collision. This is because the pickup game objects are still using normal colliders and not triggers. Remember, colliders will stop physics objects from overlapping with them, which is perfect for a wall, for example, but triggers will just notify you if something is overlapping without stopping it. You can fix this issue by making the colliders into triggers, or trigger colliders. When you turn a collider into a trigger, you can detect the contact with the trigger through on-trigger event messages. When a collider is a trigger, you can do some clever things. You could place a trigger in the middle of a doorway in, say, an adventure game. When the player enters the trigger, the minimap could update and a message could be displayed to tell them you have discovered a new route. Or, every time the player walks around a particular corner, spiders might drop from the ceiling because they have walked through a trigger. You have already used onTriggerEnter in your code, rather than onCollisionEnter. Now you just need to make sure the collider is set to be a trigger. Let's get started.
Collider was trigger was set.
And onCollisionEnter. Now you just need to make sure the collider is set to be a trigger. Let's get started.
Where the collider, where the trigger? Not able to.
Need to make sure the on trigger enter in your code rather than on collision enter. Now you just need to make sure the collider is set to be a trigger. Let's get started.
Okay.
First, check that you're not in play mode. Changes made in this mode won't be saved. Next, go to the prefabs folder in the project window and select the pickup prefab.
Now it will work. It's working. It's working. It's working. It's working. So I have started. It's totally working. Good. But speed, I have to increase the speed of the player is not so perfect as 1. No, I think it's 1. It should be 3. Okay, now it will work perfect. Now it's colliding. Really, now it's amazing, but it's little bit fast. I have to be normal. I will put 2. Okay, it will be very normal speed. 2. So fine. This will be cool. Okay.
There's one more tweak you can make to the collectible cubes, adding a rigid body component. Any game object with a collider and a rigid body is considered dynamic, which means Unity won't treat it as static or stationary. You don't want the pickup game object to be considered static, as it will take Unity longer each frame to calculate the physics, and it will do this each frame because the cubes are rotating. The solution is to add a rigid body component to the pickup objects. In the project window, go to the prefabs folder and select the pickup prefab. In the inspector, select Add Component and add a rigid body. Say
Okay, rigid body I go to add. Okay, just added.
save your changes, then test in play mode. And, the cubes all fall through the floor. The force of gravity is pulling them down, and as they are triggers, they don't collide with the floor.
Force of gravity.
If you find the rigid body component in the inspector, you'll see that you could just disable the Use Gravity checkbox, which could prevent the cubes from being pulled downwards. However, this is only a partial solution. If you do this, even though the cubes would not respond to gravity, they would still respond to physics forces. There is a better solution. Enable is kinematic. This sets the rigid
But gravity is necessary, so we will enable kinematics. Where the kinematics? This sticker is okay. It's okay. It's kinematics okay.
rigid body component as a kinematic rigid body.
Kinematics.
A kinematic rigid body will not react to physics forces, and it can be animated and moved by its transform. This is great for everything from objects with colliders, like elevators and moving platforms, to objects with triggers, like your collectible cubes that need to be animated or moved by their transform. Let's save the scene again and enter play mode to test.
Okay, save it.
Now the cubes do what they did before, but more efficiently. Excellent. So, to recap, static colliders shouldn't move, like walls and floors. Dynamic colliders can move and have a rigid body attached. Standard rigid bodies are moved using physics forces. Kinematic rigid bodies are moved using their transform. In the next section of this project, you'll count the collected objects and make a simple UI to display the player's score and messages.
It's working. It's really amazing. Really, oh, it's really amazing. It's working. Final script sample. This is final script you can use. I will use the 2.5. It will be a little faster. 2.5. This script you can use. This is the script. I can check out. The same script is there now. Okay, fine. Displaying score and text. Okay, I'm going to learn this. Displaying score and text. UI, we are going to make UI in this tutorial. This is tutorial number. Next tutorial, you can see the tutorials. The path of we have completed till here. Create now this is the create a UI text element. This is going on. Display the count value. This is next. Create a gaming method. This is and this is the final script sample. This is last one. Revise. Okay, I'm revising it. Okay, I understood what is going on. Same thing. This. So the value of electric.
In this section of the project, you'll explore counting the collected cubes, displaying text, and ending the game with a message. First things first, the collectibles. To count these, you'll need a tool to store the value of the counted collectibles, and another to add the value as we collect and count them. Let's add this functionality to the player controller script. Select the player game object in the hierarchy and open the player controller script for editing. First, let's declare a private variable to hold the count. This should be an integer variable, written as int, because the count will be a whole number. The player won't be collecting
1 second. What do you have to do?
partial objects. Underneath the rigid body variable declaration, write private int count, semicolon. Naming the variable count makes it easier to understand its role in context. The game
Okay, so I didn't count.
needs to start with a count value of 0. Each time the player picks up a new cube, it then needs to increase by 1. As the count variable is private, you won't be able to set its initial value in the inspector. You'll need to do that in this script. There are several ways you can set the starting value of count, but for this game, let's do it in the start function. In start, write count equals 0 to set the initial count value to 0, followed by a semicolon.
Okay, finally.
Next, you need to increase the count variable when the player collects a cube. These cubes are collected, or disabled to make them disappear, in the on trigger, if the other game object has the tag pickup. That means the on-trigger enter function is where you need to add the counting code. After setting the other game object's active state to false, add another line of code to add 1 to the variable count, then save it back to that same variable. This is a basic form of incrementing a value. To do this, write count equals count plus 1, then add a semicolon.
Understand automatically.
There are other ways to add, count up, or increment the value when coding for Unity, but this one is the easiest to explain visually. Now save this script and return to the Unity editor.
Saving the script.
In the next video, you'll create and configure a UI text element so that you can display the incremental count value to the player.
Okay, going to start it. Now it will increase. The value will increase by every unit. Let's see. Second. But the thing is that it's not visible, so we will make the UI. This is just a half of programming we have done. We are going to represent in UI. We create a UI text element. We have created.
Now you can store and increment the player's collectible cube count, but there's currently no way to display it. To do this, you're going to use two systems built into Unity: the User Interface, or UI system, and TextMesh Pro. Let's get started by creating a new TextMesh Pro text element in the Unity editor. First, in the hierarchy, select the Add button and go to UI, Text, TextMesh Pro. A dialog window will open to install TextMesh Pro Essentials. Select Import TMP Essentials. These resources will be added to a new folder at the root of your Unity project. Close the window when you're done. Now you'll see that some new things have appeared.
Okay. Essential is good. Yeah, essential is.
Close the window when you're done. Now you'll see that some new things have appeared in the hierarchy. Let's review them. There's Text, TMP, the UI text element. There's also a parent game object for that text element called Canvas. And another game object called Event System. These game objects are all required by the UI toolset. The single most important thing to know about these additional items is that all UI elements must be the child of a canvas to behave correctly. Rename the text element game object CountText.
Context.
Now, select the canvas and press the F key to see the entire game object in the scene view. Then, select the 2D toggle at the top of the scene view to change to 2D view.
Okay, I will also change.
The default text color is white.
I will do that thing that you are doing. Wait a second. So the 2D, 3D. I'm not able to see 2D, 3D. Okay, this is the 2D. Now I can see. Now what the ratio I have to put here?
White. The size and alignment are good, but let's add some placeholder text. In the text field, at the top of the component, add count text as your placeholder.
Context. I have to put context. Okay, this I have to. it will be outside of that. Okay, let me do the default size. Where you want to put? Here. Okay, fine. Okay, next play the video.
holder. Now, to avoid getting in the player's way, it makes sense to display the count in the upper left of the screen when the game is playing. It's currently in the centre of the scene. This is because the text element is anchored to the centre of its parent, which is the canvas. It is worth noting here that the transform component on the UI object is different from the other game objects in Unity. For UI objects, the standard transform has been replaced with a rect transform, which takes into account many specialised features necessary for a versatile UI system, including anchoring and positioning. One of the easiest ways to move the count text element into the upper left of the screen is to anchor it to the upper left corner of the canvas, rather than to its centre. To do this, select the icon at the top of the rect transform component displaying the current anchor preset. This will open the Anchors and Presets menu. Hold Shift and Alt or Option and select the top left anchor point. Holding those keys will set the pivot and position for the count text based on the new anchor. And now the UI text is up in that corner. Great.
One second. I want to do it by myself. I'm going to here. Top. First thing is top. Now it's cool. Totally cool.
It does look a little cramped though. Let's add some space between the text and the edge of the screen. The simplest way to do this is to change the rect transform component's pos x value to 10 and pos y value to -10. Now that looks better.
Now it's better.
In the next video, you'll make the UI text element display the actual count value for the game.
It's good.
Now that you've created a UI text element to display the count, let's connect this to the player controller script to get it working. In the project window, go to the scripts folder and open the player controller script in your script editor. Before you can code anything related to the TextMesh Pro element, you need to add information about it to the script. The details about the UI toolset are held in
1 second. What's easy? Left control of add to come.
what's called a namespace. You imported another namespace earlier in this project to access the Unity input system. To import the namespace for TextMesh Pro into this script, create a new line underneath the input system namespace and write using tmpro semicolon.
tmpro. Okay.
With this imported, you can now write code relating to the element. Next, underneath the public variable called speed, create a new public TextMesh Pro variable using the type TextMesh Pro UGUI called countText. Make sure to add the semicolon at the end of the variable declaration. This variable will hold a reference to the UI text component on the countText game object. Now, you need to set the starting value of the UI text property and get it to change as the count value changes throughout the game. It's worth creating a new function for that to avoid duplicating lines of code. Underneath the onMove function's closing curly brace, leave a space and write void set count text, open and closed brackets. Add a set of curly braces beneath this to contain the function body. You can now set the count text equal to the int or whole number value of count. To do this, write countText.text equals quotation mark count colon quotation mark plus count dot toString open and closed brackets semicolon. This function must be called after the line of code setting the count variable's value within the start function, because count needs to have a value that can be used to set the UI text. Let's add a call to set count text to the end of the start function. Write set count text, open and closed brackets, semicolon. The UI component's text also needs to update every time the count variable is incremented after the player collects a cube. Inside the if statement for the onTrigger enter, call the setCountText function again using the same instruction. setCountText, open and closed brackets, semicolon. Excellent.
Fine.
Save your changes and switch back to the Unity editor. Now,
Okay, I have to save the changes. The thing is that no, you have to write the script very precisely, otherwise it will make errors, lot of errors. Okay, fine. This is cool. Okay, run it. Stop it. I have to save first. Okay. Change 22. Okay. Context is there. Mathematics. That is not appearing. I think it will be.
the player controller script component has a new text property. Select the player game object in the hierarchy, then drag and drop the countText game object onto the slot to reference the UI text element. Unity will find the TextMesh Pro UGUI component on the game object and correctly associate that reference.
Okay, 1 second. Where I should put default map player input? Okay. The player should be here. Okay, fine. Next.
Now let's save, enter play.
Okay, another thing is there. Let's check out the
Play
full.
mode and test. Great. Now the count is displayed and increments correctly as the player collects cubes. Remember,
But it's not displaying for me. Let me check out what thing I've done. No. Some issues there. Don't worry. Let's check out the script. Okay. Don't worry about it. Some changes are in the script. Otherwise, so.
remember to exit play mode when you're done to create a game end message for the player.
चलो okay, just put it that go to canvas once again. Go to canvas, default text. I don't know where it is. Some issue is there. Go to play. Go to play controller. There should be some script issue. I think. Some script issue there. Hmm. Okay, it's called. Okay, it's okay. It's okay. It's okay. कॉन्टेक्स्ट कॉन्टेक्स्ट में प्ले का जो कॉन्टेक्स्ट है ना इसमें डालना है। अब ये इसमें प्ले कंट्रोल का जो स्क्रिप्ट है वो पता नहीं तो सेव नहीं हुआ है, क्या हुआ है, कुछ इश्यू आ रहा है, सेव नहीं हुआ है। UGI. This is not GUI. This should be UGI. Now save it. That's it. No, it's fine. What are you going to do? Go in the player. Yeah, just put the context. Now it's fine. Now save it. Now it will appear. This thing I was missing. The everything is completed. Mark step is completed. I didn't save. I didn't mark the UGI, but that it was missing. Now it will appear. Now next thing is lights and the sound. That should come. Otherwise everything is fine. Okay.
To finish up your UI work, let's add a simple message for the player when they've collected all the cubes. First, create another UI text object. In the hierarchy, select the Add button and go to UI, Text, Text Mesh Pro. Just like before, the new UI element has been created as a child of a Canvas game object. Rename the UI game object WinText. In the inspector, find the vertex color property in the Text Mesh Pro component and use the color picker to set this to black. Let's also make this text a little smaller.
Okay, let's one sec. Where's the color? Where's the color property? Text. This is the color property, no? Vertex color. A lot of color. I can't think of anything with it. Where is that? I'm not able to see. There's some issue. Let the video again.
Set the font size to 32.
The thing is that no, there's nothing like that. What's it? Like I put it this one, and when I gone this one, then something was there, no? But here, I think color and is that? Okay, okay, I have to open this one. Okay, it was totally close.
You could also make it bold using the B button in the font style field.
32, 32, 32, and make it bold.
In the text field, add "You win."
You win. Okay.
Lastly, let's adjust the alignment of the text to the center of the player's screen, but raised above the middle on the vertical axis, so you won't cover the player's sphere. By default, the UI text element is anchored to the center of the canvas, so you just need to raise it and move it across. In the rect transform component, set the pos x value to about 0 and the pos y to 130.
0
Let's also set the alignment to center.
and 0. Okay.
Then, save the scene and switch back to your script editor. Now you need to add a reference for this UI text to the player controller script, but as you only need to disable and enable the text,
But let me see. Okay. Is it working or not working? It's mirror. Thank you so much. It's mirror.
you can just create a reference to the game object. At the top of the script, with the other variable, create
Public is at the top.
a new public variable of the type GameObject and call it WinTextObject. Remember to add a semicolon at the end of the declaration. Next, let's set the starting state for the object to be disabled. This text should only display when the player has completed the game. Because it's a starting state, add the code disabling the UI text to the start function. Write an instruction using the same method that you use to disable the collectible cube game objects on collision. WinTextObject dot set active, open brackets, false, closed brackets, semicolon. You also need to set when the UI text game object will be activated. Let's add this to the setCountText function. Underneath the instruction setting the count value UI text, write if, open brackets, count, greater than, equals 12, closed brackets. Then add curly braces to contain the code. An important note, if you add a different number of collectible cubes to the game, perhaps a few more than 12 or a few less, your if conditional statement must reference that number.
Really cool.
Otherwise, the game end text may display too early or might not display at all. Inside the curly braces, set the WinTextObject to active. WinTextObject dot set active, open brackets,
This is very important.
true,
Check it out whether it's 12 or not. If they are not 12, then you have to make 12. Otherwise, you have to put the number of colliders, number of collectibles you have in your project. No, mine have 12. I just as it is made the replica, so I have 12. Okay, you can see. You can just count here. I am showing you. Where is that? Pick up elements here. You can count here. Just 12. Started from 1 to, you can see. 4 is missing, no? No, 4 is at 4, 5, 8, 9, 10, 12 is there. But I think so. 1 is more, no? So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1 is extra, I think. Okay, I have to cut it down. Where is that one? This last 12 is. This you have to do it. No, it's okay. I'll put this one. It's a bit. Yeah. Okay, now it's fine. Now you can see from here how it's looking. Now it's fine. Now it's 12. Okay. 1, 2, 3, 4. 1, 2, 3, 4. And you can see 1, 2. No, now it's out. You have to make this one. Okay.
Closed brackets.
1 second. What I have to do? Select it. Okay.
Semicolon. Then save your script and return to the Unity editor. Just like before, the player controller component has a new UI text property. Select the player game object in the hierarchy, then drag the WinText game object from the hierarchy into the slot.
Okay. Okay. Tablet. And then another. Where is that? This is WinText object. I have to put it here. Not WinText. Deleted. Game object or I have to or WinText game object. I have to. Do this.
Save the scene and enter play mode to test your changes.
Now when I play the game, I like see.
So, the player can collect all the cubes, see the count go up, and then receive a win message when they've collected them all. Awesome! In the final section of this project, you'll create a build of your game and deploy it using a standalone player. You're almost finished.
Oh, let me freeze this game. 7. Okay. This is 8. This is 9. Coming to near power boundary. Oh, wasted. I think some. Left 10 and one is remaining. Only one is remaining, just to capture it. Just come inside. Yeah, I win. Now I finally win. Thank you so much for having this lecture. So it's now over. Now next lesson is coming. You can see just crossing, and you win. you win. This will come here. You can see in the full screen also. Maximize it. You win. This will be there. This is the script that we already write. Basic 2D game I will not do, because thing is that I will do after, because I am creating 3D game first, so I will do whenever I require it. Okay, now I don't require it. First go. Okay, I'm going to this one. First basic 3D game is completed. Heading AI navigation. This is there. Okay. Exercise. This one. Here effective animation. So that's not just lightning is there. Many things is there. Very nice. So I am going to take some break. Okay, because bio break is there. Okay, fine. Okay, going to start it. So I already did it. So okay. Okay, fine. Set up a basic. This thing we will do. Set up basic Unity 3D environment with players and enemy game object. Implement nav mesh for AI based enemy navigation. Add static and dynamic obstacles to challenge the player. Okay, this thing. For win and lose condition using Unity scripting. Is that no? You have to do. I already played it.
The game will be a lot more exciting if there's some risk involved. In this tutorial, you'll create an enemy game object that will chase the player. Let's start by creating a new empty game object. Right-click in the hierarchy and select Create Empty. Rename it to Enemy. Reset the transform of the enemy game object to position it at 0, 0, 0. You can do this by selecting the enemy game object in the hierarchy and then click on the gear.
One second. Let me create the first empty game object enemy. But I think it's a cube or something that stuff.
Icon in the inspector and choose Reset. Inside the enemy game object, you will create a cube to represent the enemy's body. Right-click on the enemy game object, select 3D object and choose.
Okay, let me put 0, 0, 0, 0. Okay, fine.
Cube.
Okay.
Name the cube Enemy Body. Adjust the scale of the enemy body to make it a bit taller. In the inspector, locate the scale values and set them to 0.5, 1, and 0.5. Set the position of the enemy body to 0, 0.5, 0 to position it above the ground. Great! Now let's create a material for our enemy and assign it to the enemy body cube. Open the Assets folder in the project window and navigate to Materials. If there isn't a Materials folder, you can create one by right-clicking in the project window, selecting Create, and then choosing Folder. Name the folder Materials. Right-click inside the Materials folder, select Create, and then select Material.
One second.
Rename
Yeah, decrease the speed. It is very difficult for me.
the Materials folder. You can create one by right-clicking in the project window, selecting Create, and then choosing Folder. Name the folder Materials. Right-click inside the Materials folder, select Create, and then select Material. Rename the material to Enemy.
Anyway,
With the enemy material selected, in the inspector, locate the base map color property and set it to whatever color you want for your enemy. Now simply drag and drop the enemy material onto the enemy body cube in the scene view or hierarchy. You now have an enemy game object in the game, but it won't move around yet. We'll get started on that next.
okay, I do this already. I can put whatever you want.
The Unity NavMesh is a tool for implementing efficient pathfinding, enabling AI agents to navigate complex environments, avoiding obstacles along the way. In this tutorial, you'll set up the NavMesh for your scene. Start by selecting the scene geometry where you want the enemy to be able to walk. In this case, you'll select the ground game object. With the ground selected, in the inspector, select Add Component. In the Add Component menu, search for and select NavMesh Surface. The NavMesh Surface component represents the walkable area for a NavMesh agent. Select Bake in the NavMesh Surface component. This will initiate the process of generating the NavMesh based on the scene geometry and the specified settings. After the baking process is complete, the NavMesh will be displayed in the scene as a blue overlay. But there's a problem. The pickups are currently being factored into the NavMesh, with the enemy either going around them or walking over them. For this game, we want the enemy to ignore these pickup objects entirely. In the inspector, in the NavMesh Surface component settings, locate the Object Collection section. Set the Collection Objects drop-down to Current Object Hierarchy.
One second.
This ensures objects entirely. But this will initiate the process of generating the NavMesh based on the scene geometry and the specified settings. After the baking process is complete, the NavMesh will be displayed in the scene as a blue overlay. But there's a problem. The pickups are currently being factored into the NavMesh, with the enemy either going around them or walking over them. For this game, we want the enemy to ignore these pickup objects entirely. In the inspector, in the NavMesh Surface component settings, locate the Object Collection section. Set the Collection Objects drop-down to Current Object Hierarchy. This ensures that the NavMesh only takes the ground object and any of its child objects into consideration, and therefore ignores the pickup objects when baking the mesh. Select the Bake button again. The pickup collectibles are now ignored in the NavMesh. You now have the NavMesh set up for your scene. The enemy won't navigate on it yet though, you'll do that next.
Okay. Fine. It's really very from now onwards I am going to follow the Pomodoro rule. 25 minutes study, then 5-minute break. It's very difficult to study long hours. It really becomes very difficult. So become highly productivity if I follow Pomodoro rule. Otherwise, it will be very difficult.
In this section, you will set up the enemy with the necessary components to chase the player around the scene. First, let's make the enemy a nav mesh agent. This will allow the enemy to detect the nav meshes in
One second. Decrease the speed, otherwise it's very difficult for me. Okay.
the scene, calculate movement paths, and navigate around obstacles. So
One second, what she said, again repeat it.
in this section, you will set up the enemy with the necessary components to chase the player around the scene. First, let's make the enemy a nav mesh agent. This will allow the enemy to detect the nav.
One second, I have some break, otherwise it's very